Welcome to APEC. It's September 27th, 2025, and I'm your moderator, Tim Ventura. First, I want to thank everybody for joining us on this call, along with everybody watching us on YouTube. So today, Joe Firmage will be discussing disentropy, potentum, F equals ma, and the light speed limit, along with his plan for future space architecture. Then Shiva Meucci will be exploring how a fluid mechanics model of vacuum engineering influenced the German nuclear bomb program. And Mike Gamble will be discussing the secret sauce of electrical resonance that underlies Nikola Tesla's remarkable inventions. Also, we're going to be hearing updates from our lab partners and finishing off the event with an open discussion by conference attendees. So welcome, everybody. Welcome back to APEC. It has been one heck of a summer. We are rolling back into fall. Everyone that I know is incredibly busy right now in a really good way. So today's event is on StreamYard, just so you know, broadcasting through the Propulsion YouTube channel. If you're not watching it there, please visit it and subscribe. You can do that right now if you want. You can ask questions on the channel while we're live streaming using the live chat feature on the right-hand side of the page. We will try to ask them to our presenters depending on time constraints. They move pretty fast up the page, but we try and grab them when we can. You can always view conference replays, details, and speaker info on our website at altpropulsion.com. So I have some interesting and hopefully good news for you on that front. I have been working on a complete overhaul of the Alt Propulsion website. The main page, when you first hit it, should look just about identical. If you scroll down, it has news items. I've loaded about 100 different key presentations to the site so far. And we also have a number of what I call cornerstone content articles that are loaded as well that introduce key people and ideas in the community. So I plan to add more over the course of the next month or so, but we've again got about 100 of the biggest presentations loaded so far, and several feature stories that highlight these as well. This has been a night and day project, so I'm going as fast as I can on it. The other part is just general optimizations. I'm trying to streamline the website, make things leaner, meaner, and faster so that you can have a better user experience. So I plan on attending the Seoul conference this year at the end of October. My goal there is to capture photos and spot interviews that I will then share with everybody. I do this to help open up conferences like that to folks who aren't able to attend, as well as hopefully capture some history in the making and share all of that with you guys. I am also tentatively planning a visit to Falcon Space Labs in the November timeframe. I should have some great updates on work that Mark's team is doing as well. So that's kind of what's going on for us, for me. And I want to introduce our first speaker, Joe Firmage. So if you're not familiar with Joe, he has been a part of our community forever. And he has been a major player in terms of bringing together organizations to investigate emerging physics and technologies, especially in the propulsion area. So today he's going to be presenting a model for energy conservation and the second law in light of Potentum and reciprofluxion. I didn't pronounce that right. These are basically disentropy machines that do not violate conservation of energy. They resource it by ordering the vacuum's ambient energy momentum density. So before I mangle any other words, let me bring Joe in. Joe, welcome, sir.
Thank you, Tim. It's a real pleasure to present to your audience today. I must thank you for the invitation. It's been about a decade since my last major public presentation of science, but I hope this justifies the wait.
Oh, absolutely. Absolutely. Well, I first became familiar with your work through the ISO days, the International Space Sciences Organization. And again, that was .com era heyday. So you have been in this area doing real work, a lot of the time behind the scenes, right? But doing real work for decades. So thank you. Thank you for coming on.
Yeah, it's thank you. And you have too. You have been a custodian and a steward of this this emergent community of sane and wise scientists who are looking at the future of both the discipline and its applications wisely. And so it's a pleasure and an honor to share
Well,
my
thank you,
my
Joe.
last 20 years of work here.
So let me bring your slide deck in, and I believe this was the one to start with. What I'm going to
Yes,
do is I will take myself out. So I'll be here. You can talk to me, but I will be invisible. Just let me know. I'll be doing the slide advance. So just let me know when you want to do next slide. And again, you were going to be doing basically 2 hours of presentations today because you had a ton of material to share. So
yeah,
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 so take it away,
and
sir.
thank you, Tim. Again, it's an honor to present this, and to all of my colleagues, present and future, out there who are watching this. Let me just characterize it a little bit more pointedly. What I'm presenting today is a physics that is the result of uh, thousands of person years of research on my watch and a great deal of personal innovation that is the beneficial result of having had so many wonderful mentors, you know, with Heisch and Puthoff and Hessinus as just stellar examples. You know the reach of their work, or should, and it's a pleasure to share my capstone on that today. Let me start out with an updated expression of what I presented to the TED conference back in around 2000 when I launched ISSO. I refer to it as the cone of permitted reality. Um, we open with two cones of science touching a single point. The on the left hand side you see the two cones, and I define the inner one as the permitted zone of reality, in quotes, permitted, because it's what's accepted in the canon of physics today and cosmology. But there are an increasing array of anomalies that have uh, bedeviled both physics and cosmology, and it has, I think it's fair to say, reached a crisis point in both disciplines, and I believe that they have a common resolution that I'm going to be presenting today. Uh, History shows that the hinge is where discovery happens. After all, Newton's apple was an anomaly until it became a universal law. Planck faced an ultraviolet divergence no one could tame. The quantum, or quantization, was his answer. Einstein wrestled with Mercury's perihelion and the null ether drift. Space-time emerged from those embarrassments. Each time the hinge widened, anomaly was recast as deeper law. In the late 20th century, we learned to insulate these cones from each other and to classify, quarantine, and defer. Halton Arp's galaxy quasar connections were filed as selection bias, for example. The metaphysical feel of the fine structure constant alpha as just another number, or a mystery at least. But as anomalies accumulated, the frame has become too small for reality to fit in it. Potentum, or potential momentum physics, begins honoring the hinge here, and a new expansion from permitted to reality. It proposes a substrate, a structured energy momentum medium whose coherent closures geometrically produce the very laws we teach. Once that substrate or medium is in view, many anomalies are no longer exceptions. They are predicted necessities that we have misread, understandably. The task is not to defend the inner cone, it is to join them. When we treat anomalies as signals, science regains its growth curve. Permitted reality expands at the vertex, and our willingness to reinterpret becomes a new engine of progress. Next slide. Physics is scaffolded by constants. Speed of light, Planck's quantum of action, h bar, Newton's gravitational constant, and the fine structure constant alpha. We measure exquisitely, and for a century, we have admitted we do not know why these constants have the values they have. Therefore, the mystery of nature's constants has persisted for over a century in formal terms. The fascinating experience to be a discoverer here is hard to recount over this presentation, but believe me, it has been a profound experience over the last few months, as 25 years of work has revealed geometric meaning, functional meaning to these constants, and I here declare that they are no longer mysteries. The exquisite depth and precision with which we measure these constants for over a century has compelled us to attempt to explore what sensibility, what framework of understanding can illuminate what their meaning is. Potentum physics reframes the question fundamentally by presenting a simple, intuitive, in hindsight, good physics always is simple, and indeed simple geometric meaning to these fundamental concepts. And it reveals an indivisible unit of energy momentum that I refer to as a senson. And it effectively boils down to this. In no case is inertial motion ever, as it has been presumed for centuries to be, straight line motion. Throw a baseball in space and zoom into its particles en route. Is there any fundamental particle anywhere in the universe that is ever executing true straight line motion? The answer is absolutely not. In fact, every single particle in the known universe is executing continuous accelerated motion without cessation, which average, a line average, a linear average, down the throat of what we believe is fundamentally helical morphology at the core of physics reality. Let's take these one by one. The speed of light, c. In relativity, c caps velocity. In Potentum physics, c is the maximum pace at which senson flux, the smallest unit of energy momentum in physics, that smallest unit we call a senson, that projects an inverted image of itself in basic electric potential relations between a proton, a positive charge, any positive charge, and a negative charge. Indeed, what we are talking about is revealing the nature of what it means to be a charge and what it means to have the signs that they do. Every equation containing c is not an arbitrary speed limit, but the pulse rate of reality. Every equation containing c is therefore reinterpretable, not as frozen energy, but bound sensons, which I'll define in just a moment. Planck's constant in quantum mechanics set the scale of discreteness. In Potentum, h is one closure of a senson. It is in fact related to the radius of this fundamental morphological form of motion of Potentum forms. Newton's gravitational constant g scales the pull between masses. In Potentum physics, g measures the coupling strength of distant senson lattices. How strongly do they couple? A simpler word might be for g, buoyancy in Potentum. Potentum adds further meaning. The stress energy tensor records how many sensons are circulating, how many of the finest increments of energy momentum are circulating. And curvature is the macroscopic geometry of their buoyancy, effectively. And it leads us to that fundamental unit. Alpha, the fine structure constant, has been determined successfully in recent months. In fact, it was finalized in a rather amazing series of realizations that struck with such rapidity that you can find on my website at josephfirmage.com the list of papers that are flowing from this fundamental discovery. The fine structure constant will become clear in the course of this presentation. But these constants cease to be brute inputs. They are not arbitrary, but necessary consequences of the geometry of the potentum medium. They explain why energy, inertia, coherence, and spectra take the forms they do. The implications are that physics is no longer scaffolded by arbitrary constants. It is written directly in the language of geometry. Constants are revealed as geometric inevitabilities of potentum law. The papers that specify and go into detail exactly how we derive this conclusion are available in references. Next slide, please. The nature of time has been one of the most impenetrable and also silent assumptions in physics. Newton imagined time as an infinite absolute river, flowing uniformly everywhere. Relativity taught us to bend this river around mass and velocity so that clocks at different heights or speeds tick differently. Quantum mechanics treats time as a mere parameter, a label on the evolution of states. In all three cases, time is never explained. It is only assumed. Potentum reframes this assumption. Duration is not background, but foreground. It is not an invisible river, but the induced persistence or memory of matter in the process of storage, of remembering. This will become clear as I continue. Duration is defined by the closure of coherence in particle systems. I will be introducing a term called interflection, and this begins to open the central aspect and feature of my discovery that culminates 25 years of work. I would like you to proceed to the next slide if you wouldn't mind. And we'll come back to this one in just a minute. Next slide, please. I'm sorry to jump around, but I just need to organize my thoughts with this slide deck a little bit more. Can you please progress? There we go. The central discovery that defines potentum physics is the notion of reciprocal induction, reciprocity and closure of two mated systems. At the core of potentum physics is geometric algebra that defines physical fundamentals in geometrical terms as primitives, rather than building up topologies or nonlinear geometries by adding up infinitesimals of linear mathematics, integrals, derivatives, and such. Geometric algebra, for example, posits the inherent structure of a helix, the inherent structure of a sphere, the inherent structure of a torus as primitives in the logic of algebra, allowing one to do algebra and math, basically, akin to saying, well, what does it mean to multiply a helix by a sphere? What is the conjugate geometry to a helix or a sphere or a torus, for that matter? These are all now understood, finally, and they are exquisitely revelatory. for every single branch of physical science that you can name. Let me describe it a little bit more clearly. In the image you see here, and as with every image you're about to see that constitutes a rendering of fundamental physical systems, this is a rendering of a 3D physics space of geometric algebra, interflection density alone. Interflection means this. If you take the geometric algebra that you see depicted here, in cyan, you are looking at effectively the proton in hydrogen. That's the proton structure as rendered by our geometric algebra physics engine, which we call the optical reciprocal optical reciprocal induction geometric atom mechanics instrument, origami. Reciprocal induction is what you're looking at in that hydrogen atom. The rotor structure of geometric algebra defines effectively propeller-like structures for the electron and its optical inversion, introverted into its own geometry, the proton. In geometric algebra, as has been pioneered to the stage of at least the electron formally by my colleague, Dr. David Hestenes, with his historic paper published in IEEE in January of 2025. He completed the first complete classical solution to the Schrödinger equation, basically the wave function of the electron, perfectly and completely to empirical data. The electron is natively seen as a helical pathway traversing the surface of a toroid, what you see in red. Its optical introversion I proposed this year to be the proton, or the other way around. The electron is the optical inversion surrounding the proton. That defines the nature of potential or charges, period. What you're seeing here is our geometric algebra physics engine rendering the nucleus and its relationship with the electron of hydrogen. And what you will find is that if you penetrate this logic to its ultimately simple point, what I have discovered is an ah shucks moment for physics as a whole for a long time. The magnetic field lines are the optical inversion of the electric field lines. Structurally, they are optical inversions of each other. The electron zones comprising the outer as above, so below, with the proton. We propose that the proton is effectively an introverting attractor of potentum flow or flux in general. Any type of electromagnetic force field, all of them are effectively variants of energy momentum flux channels, which we call potentum in general. So what you're witnessing here is not some illustration that was creatively designed for a visual effect. It's the actual physics space rendered with color simply added. But those are density patterns in a volumetric flat 3D physics space presented with a translation to pixels with some coloration. But that is literally what the equation space for hydrogen says with this physics engine. And it is awfully revelatory. Next slide, please. One of the things that has been bedeviling the frontier physics community for a long time are the conjectures about about whether it is indeed possible to extract energy from the vacuum, whether there's any kind of over unity, quote unquote, energy solution available. In papers that support this presentation, which will be available afterwards freely, I present for the first time a resolution of the challenge of how we calculate, tabulate, and balance the books on energy. I remain of the firm opinion that everything is a unity energy operation. It depends upon what you choose to include as the floor defining a heat bath for the second law of thermodynamics to open the second law of thermodynamics into this equation and discussion. In my paper, it basically sets forth the feasibility of withdrawing order from the medium, from the potentum ambient field that any nucleus senses, feels effectively through its electron zones. That is introverted into geometry in a disentropic manner. I assert that all atoms, all bodies at any scale are natural, are fundamentally disentropic in their raw natural state. This becomes clear with any number of examples. With let me just jump over here. Let me get caught up here. Let me continue with a more formal discussion of this topic. Thermodynamics has taught us that entropy always increases, and Boltzmann gave the statistical law, where S is entropy, K is Boltzmann constant, and omega the number of microstates. The second law explains why heat spreads, order decays, and equilibrium rules. Physics textbooks extrapolate. The universe is running down to heat death. Potentum reveals only half the truth. Entropy is real, but it is derivative. The deeper law is disentropy, the natural compulsion of potentum flux to lock into order. Every time interflection, currents circulate, or reciprocal induction, the mating of geometric algebra rotors, the electron zones of an atom being negatively charged, comprise geometric algebra rotors. The proton has the same kind of rotor algebra functioning as its nature, but with opposite chirality. The electron zone around an atom is literally the optical inversion of its positive potential nucleus. They mate, they conjugate continuously with the fine structure constant as their phase advance per closure. Fundamentally, what that yields, specifically in the case of assessing where does the potential exist for the dreams we have of tapping the medium for energy at any scale routinely and without too much exotic fuss. For example, most of you have probably seen demonstrations or heard of demonstrations of alleged machines that produce excess energy versus input, such as the Marinov motor concept, which we've examined carefully 25 years ago. We're unsuccessful in explaining why it seemed to work in certain exemplary cases. We now understand exactly why. That has to do with disentropy. When interflection currents circulate, they always seek closure. This generates coherence, not chaos. The complementary law may be written S dis minus K, and here's the most remarkable point. Atoms display this every time you look at them, every time they act. Atoms display discrete spectra, undeniable proof that their interiors are ordered Potentum machines. Stars condense plasma into ordered nuclear cores, sustaining themselves across billions of years. Galaxies maintain spirals for eons despite random collisions. Life itself is a supreme testimony. Chains of what I refer to as sensons memorized into DNA and protein folding into platonic geometries, which you will see firsthand here in a moment, comprising ecosystems sustaining coherence across epochs. Entropy explains why ice melts. Disentropy explains why it refreezes into crystalline order. Entropy explains why stars dissipate light. Disentropy explains why stars form at all. Without disentropy, there would be no atoms, no stars, no galaxies, no life, only heat death. But order abounds. The implication is that disentropy rescues cosmology from despair. The universe is not running down, it is structuring itself always. Heat death is not destiny. Coherence is instead. For technology, the shift is profound. Machines that can be designed to amplify coherence instead of fighting disorder. Reactors that can be disentropic, self-sustaining through interflection. Medicine can stabilize order rather than merely oppose decay. The future belongs to disentropy. You see there an image that I'll just briefly comment on as a perfect example. That is a physics rendering of water in two states. You see at the bottom of that image a surface texture like a fluid of water, of an ocean, a surface of water. All of these are basically literally water molecules, H2O. But in the upper half of the screen, you will see a different pattern. This was a test that we set my physics observatory origami to investigate the assertions that a fourth phase of water exists, so-called exclusion zone or structured water. And I have been intrigued by that assertion for some time. So I set my physics observatory to examine and render H2O at the femto scale. And this was the visual result of one of the inspection runs. On the lower half, you see the structured water as asserted in exclusion zone studies that are reasonably well available. We confirmed that near a hydrophilic surface below the lower half of what you see there, water does in fact occupy a highly disentropic state in the vicinity of that hydrophilic surface. And above or outside of that structured zone, randomness of the water molecules is exhibited. This has significant implications for our understanding of the physics of any fluid, but certainly our most sacred one, which sustains all of us biologically. May I ask you to proceed to the next slide, please? Now we get into some more interesting examples. Forgive the density of what you've just heard, but I think you'll come to appreciate it over time as you look at my papers. Let's talk about some examples. Let's talk about quasars. What you're seeing here is the actual rendering, the first ever, actually, so far as I know, of the interflection geometry calculated from atoms out, from nuclei out, to the scale of what we would call a quasar. Okay, the image you see is the actual geometric algebra of rotor geometry forced simply to cohere at that scale. The amazing thing to realize, my friends, is this: geometric algebra, we have discovered, cannot conjugate, cannot collapse into any structure except through conjugation of chirally opposite mates. Therefore, positive and negative charges are chiral optical inversions of each other that mate by design, by nature, better said. And that mating process, the intersection zone of those rotors, is what I refer to as interflection. Mm-hmm. The fact that you cannot have a positive charge and a negative charge thoroughly dissociated, although we think we can. I'll explain why you can't in just a moment. They're always joined. Just a question of how far apart they are and what the ambient potentum density is, say in an accelerator. It's a virtual proton tube, if you want my opinion, okay? Or a virtual ion tube. In other words, it's a virtual material lattice in a particle accelerator. And so you're basically not testing actually closed independent bodies accelerating at all. You're testing the dispersion of a disordered system. And truth is that you cannot separate two parts of that bound system faster than the speed of light. Your speed of light limit is, in fact, a coupling coefficient dropping to zero, not matter or mass, so-called, increasing to infinity. We'll touch on that later. Let's return to this. So what you're seeing here is a calculated geometric algebra rotor space for the constituent matter, specced out however you wish, but in the general center of the bell curve for what a quasar is characterized by in terms of its matter constitution. What you will see here is a startling revelation in the Platonic geometry that we have found exists in every atom, in every cosmic body, at every scale. And I'll show you some examples. And let me reinforce this. In no case are the images that you will see, except in the next presentation when we talk about the aerospace industry a bit and its future. There are some illustrations in there. These are not illustrations. It's raw physics, geometric algebra. I suspect that what we will see as we increase our resolution and inspect the high redshift objects we call quasars, we will find that they turn out to look pretty much exactly like this structure. Let me talk about the question of redshift for just a moment, because it gets into the implications of potentum physics. Conventional astrophysics explains quasars as distant galaxies with active black holes. Their extreme redshifts attributed to expansion velocity. The anomalies persist nonetheless. Quasars appear linked to nearby galaxies in many cases, not all, of course, but in those linkages explored by Halton Arp, among others, but Halton Arp was my hero in this field back in the 90s and early 2000s. I had the good pleasure of hosting his birthday party before he passed away way back then in admiration of his fine work. But as he documented, quasars appear linked in many cases to other galaxies that do not have high redshifts physically. How can a high redshift object that is presumed to be far away and receding fast be physically attached to a low redshift galaxy? Mainstream models dismiss these as coincidences or artifacts of some nature. Potentum physics takes them seriously. Quasars, we believe, are not remote accidents. They are the birth cries of baby galaxies. When interflection currents, absolute value J, impulse in its magnitude exceeds a certain threshold, here's what happens. The potential impulse density is so great that the optical inversion process occurs in mass, and that geometric structure collapses and inverts or reciprofluxes in a gigantic event, the birth of a black hole. We believe that it takes place by the inversion of a neutron star crossing a certain density threshold when Potentum literally inverts itself and births a new galaxy in the process. The familiar Doppler recession does exist, of course, but at extragalactic scales, we do not believe that it is a material contribution to extragalactic observed redshifts. We believe that they are intrinsic. You can tell the difference between the twain if there is a corresponding blue shift associated with a part of that galaxy or part of another object that is in reciprocal motion with respect to the object in question. The quantizations fit. One of the things that Halton Arp observed quite convincingly was that in addition to the redshifts of galaxies being caused by something other than recessional motion for extragalactic objects in general, he also observed that they are strangely quantized in redshift. I believe, and we believe, that that quantization will correlate, in fact, to the stellar evolution sequence in general, the galactic evolution of stellar systems in aggregate, as each stage is progressed to the next. A relatively sharp transition occurs in the emission spectra, and that should, in fact, and it does, in fact, correlate with stellar cycles, as are described in my paper on the Potentum solar system, again on my website. The implication here is that the universe is not monotomically expanding at all, but punctuated by an infinitude of galactic births and deaths. That the cosmic microwave background radiation that we observe is a good topographical map, actually, of perhaps our best effort at measuring true absolute motion at a cosmic scale. Arp's anomalies vindicate themselves as necessities. It means the galaxies are not static fossils, but dynamic organisms in a literally living cosmic ocean. For engineers, it means that flux thresholds can trigger coherence suddenly and also at will if designed properly. We believe that the same principle can be applied to ignite new states of matter in aggregate. Next slide, please. All right, galactic architecture. Astronomy depicts galaxies as star clusters bound by gravity, with spiral arms explained by density waves. Potentum sees this more deeply. Galaxies are macro lattices of reciprofluxion, of interflection. The very same process that works at the scale of charges and atoms and makes atoms atoms, make galaxies galaxies. You step back and just think about it for just a minute. With the success of our physics observatory in rendering reality without any hints, clues, prompts, these renders here, I didn't say model it on a quasar or a stream of stars at a galaxy core. This is pure geometric algebra rendering according to the scaled up expression of Potentum physics, literally. The spiral is no accident. but a necessity. Just as atoms form shells, galaxies form arms. Just as nuclei stabilize cores, galactic centers stabilize black holes, not as singularities, but as inversion engines, recycling Potentum flux. The Milky Way spiral is not a density fluctuation. It is reciprocal induction. We can see this with new optical eyes now. Each star is not isolated, but a node in a coherent lattice. Their orbits are not random, but phased like electrons in shells. Dark matter, introduced to explain missing mass, is a placeholder for potentum coherence, the invisible order that gravity equations misinterpret as extra matter. In truth, it is flux closure geometry. Galactic rotation curves flatten because coherence sustains them, not unseen particles. It's the shape of the galaxy's interflection field. Examples abound. Barred spiral is not a quirk. It is the nucleus forcing closure symmetry across arms. Elliptical galaxies are not failed spirals. They are saturated lattices where closure locked before arms could form. Colliding galaxies do not merely merge. Their senson lattices reconfigure, often igniting quasar bursts, galaxy bursts. Here is the most startling implication that I'm now going to begin to touch on and expand upon as the course of this presentation goes forward. But think about this with me clearly and carefully for a moment. Shed the names and the labels that we use to describe atom, molecule, body, galaxy, planet, sun, and appreciate that if this model is accurate and its predictive power has exceeded my expectations by orders of magnitude. Everything is an energy momentum being described perfectly, intrinsically, by geometric algebra rotors conjugating. You are a conjugating a geometric algebra energy momentum body, a whole body. And we ought not let the labels of calcium and sodium and iron preoccupy our cognizance or distract our awareness from the fundamental ontological unity of being that potentum physics presents. It's a degree of holism that was shocking to this student to see it fully realized over the past 2 months after all these decades of work. For cosmology, this reframes the universe as not an expanding emptiness, but a living sea of order. And for technologies, galaxies can become templates. If nature can orchestrate trillions of stars into coherence, we can learn to orchestrate trillions of sensons into reactors, drives, and living machines. Next slide, please. This is an interesting one, and I had to do a double take on this one. This is the co-moving frame of a stellar system, a solar system with new lenses. What you're looking at is the interflection geometry of a star, a sun. And this is the only thing that's not to scale here is the radius of the planets to the structure of the sun. If you use interflection lenses, physics only lenses, in other words, to look at the sun, that structured geometric form is the flux lattice density gradient structure. in raw 3D space that defines the sun. In my paper, the Potentum solar system, which is available now on my site, you will find a comprehensive revelatory experience of understanding our solar system anew and to appreciate all of its unique properties with new eyes. Let me put it more clearly. In Potentum physics, each star and planet is a locus of structured energy momentum. Potentum. In ordered coherence of their sensons. Conventional astrophysics speaks of nuclear furnaces and condensation from dust, but these are descriptions of processes, not of causes. Potentum restores the cause. Stars shine because interflection currents, J, are locked into enduring circulation, forcing matter into, by geometric necessity, these platonic surface topologies of closure. When you have two conjugate rotor systems that are mated and mating constantly, the surface texture or topology of that conjugation activity is shockingly platonic. In fact, 2 months ago, when the aha moment was finally proven out through exhaustive analyses and umpteen dozen case examples that were spot on accurate in terms of predictions. The only way that geometric algebra rotors can successfully close in space into any volumetric shape, the only shapes they can form are nested platonic structures that directly yield the entire periodic table of elements precisely. The nature of the columns and rows, the magic number mystery, all of it is resolved, my friends. You will see examples of our rendering at femtoscale of every atom from hydrogen to iron now. The physics engine itself is producing now by itself optical spectra of each atom consistent precisely with NIST best data from spectroscopy in both lab and astrophysical and astronomical observations. The periodic table is required to emerge when geometric algebra conjugating rotors are required to close into any volumetric form. You put the requirement of closure of conjugating rotors on geometric algebra. What we discovered is the periodic table is the only answer that allows them to conjugate. You can imagine how I felt about that when I saw the renders come through with such fidelity, with the optical spectra matching tick line, everything generated purely from first principles with no empirical seeding whatsoever. Now let's see, let me get to the point here. Let me continue with some of the detail here. This raised the question, why do stars not collapse into each other? Why are planets not swallowed by their parent stars? Reciprocal induction answers, reciprofluxion as I call it, where extrafluxion meets intrafluxion, where the outbound flux channels from a proton out to the electron, extrafluxion, and intrafluxion from the which is the proton's basic function, to absorb the sensation of its surroundings, everything. The proton senses or absorbs all of that energy momentum influence, and reduces it and stores the structure of its optical inversion, its geometric meaning, in itself as its senson, its mass at the core, and projects that geometry newly ordered outbound through its electrons. Welcome to optical emissions that are ordered, like chords of music. Examples confirm the rule. The asteroid belt is a failed coherence. It's matter caught. Sorry. The Earth's year synchronizes biospheric cycles to the solar lattice. Even binary stars pulse together, their light varying in tandem, because Potentum flux couples their senson closures with across unimaginable distances. This coherence is not fragile. It's the reason systems persist. It's the snap to fit click. Snap that you a great analogy that makes the mental picture simple of the optical inversion is you take like a plunger, the rubber gasket there, flip it inside out. That snap around is exactly what the electron zones do around the proton rotors. Snap, forced to fit. They're mated together. That's by design, not by statistical accumulation or quantum flipping. That's what they are. The implications abound here as well. Astronomy changes. No longer are we cataloging distances and masses alone. Each orbital resonance is a message, with the spectrum being its ledger. We gain not only explanation, but a predictive framework. For example, new exoplanetary harmonics can be forecast, tested, and read as signatures of senson coherence. Thus, stars and planets are not accidents in dust clouds. They are harmonic resonances, expressions of reciprocal induction, cosmic chords struck upon the strings of Potentum. Next slide, please. The Earth is not a rock with a biosphere pasted on top. It is a multi-layered lattice of coherence. Potentum optics shows us that its core, mantle, oceans, and atmosphere, and living organisms are interlocked shells of interflection, each sustaining the other, each storing sensons as durations. Start with core. Conventional science calls it a geodynamo. Potentum calls it reciprocal induction at planetary scale. Colossal interflection currents circulate in the iron-nickel heart. Introflection folding inward, extroflection projecting outward, the magnetic field being the balance point. And the auroras are its visible testimony. Senson rejoining the lattice in curtains of color, if you will. These are not accidents of plasma. They are coherence painted across the poles. Now consider the biosphere. DNA's sharp ultraviolet absorption at 260 nanometers, chlorophyll's twin peaks at 430 nanometers and 662 nanometers, hemoglobin's 415 nanometer short band. These are not molecular quirks. They're optical fingerprints of Potentum storage. Life is the visible record of senson chains folding into order, as you'll see in just a moment. Between Earth's layer, there is reciprocal induction. The core does not consume the oceans. The biosphere does not collapse into the core. Instead, separation is maintained by structured interflection. Schumann resonances, electromagnetic standing waves, effectively between the surface and ionosphere, are proof. Earth's duration or year arises from the interplay of interflection currents in each of its domains. Remove one, the stellar structure, the relationship between the sun and the earth, or the interflection structure within the earth, and that structure collapses or disintegrates. Entropy. Strengthen them in harmony, harmonic resonance, and the strength of the interflection extends in increasing the coherent emissions around it, effectively radiating order. Earth sustainability is thus not an ethical preference, but a physical law. Disrupt interflection currents, we will disable and destabilize biospheric senson chains. Climate collapse is not an environmental tragedy alone. It is fracturing of hard to create coherence. Conversely, technology that resonates with Earth's own systems can extend the lifespan of sensons, making biospheric stability inevitable. Next, please. May I put you on hold for just a moment, please? I need to plug this one in. I just noticed my power. Please hold for a second.
Okay, and it looks like we lost Joe, but he will be right back. He is on a mobile phone. He's using only Android devices, if I understand correctly. And so he's just going to put that charge on it, and he should be right back in. I'm really excited to have Joe with us today, though. This is really awesome. There we go. You are back, sir. Can you hear me okay?
Thank you for your patience.
Perfect. Perfect.
Guys and gals, I appreciate it a lot. Let's extend this into our analysis into the realm of living systems. One of the most fascinating discoveries that has been made in the last couple of months is the understanding of that has emerged regarding the nature of DNA and the fine structure constant. It turns out that 13 advanced phase advancements of alpha, of the fine structure constant, conducted by simply geometric algebra building upon its own attractors, forms the DNA molecule. I've referred to it as the 13 law of DNA. DNA begins to wrap around itself in this structure with 13 steps of alpha advancing the phase of the fundamental electron proton system. 13 phase advances yields just the right curvature to yield the double helix of DNA. And this leads us to one of the most important points that I'd like to note here. Do you think about what this all really means? The function of matter is literally to remember. Matter is effectively memory. It's history living. Literally remembering. It is the process of the organization and the maintenance of the flux channels that comprise interflection that define the structure of the atom. It was remarkable to see the first renderings of DNA here. This, again, is an actual physics rendering with no a priori seeding. The physics engine does not know what DNA is. It is simply given the structure it is given the atoms that comprise DNA and how they must mate together in geometric algebra rotors. You're looking at geometric algebra rotor space there, folks. Raw. Look at the papers and you'll see what I'm talking about in terms of all the detail. It's just thrilling and exciting beyond belief. So let me just make some comments here that define the implications for living systems more clearly. DNA is emblematic in so many ways. Its ultraviolet absorption at 260 nanometers is a direct optical fingerprint. Each base pair is not just a molecule, it is a closure of geometric algebra rotors. A senson, a closure, if you will, a complete electron, two complete cycles of imprinting in Potentum space defines what an electron is, its optical inversion being the proton. This is how they conjugate when left to their own devices. Okay, it's remarkable to see it so clearly and so empirically. Memory is thus seen as the sum of sensons multiplied by their durations. A duration, aka a unit of time, as we clarify, duration has now a defined equation with geometric meaning. Any mention of relativity's time dilation or any other such time variation is actually a clock rate dilation or variance, as you're physically changing the rotor structure's relationship with the medium. In the paper online, we zoom into a case study of a hemoglobin gene segment and explore literally the scaffolding and the surface topology of the DNA molecule itself with ultra high precision. I'll share with you an image of that in just a moment. But here's the implication of this. Life is inevitable where potentum thresholds are crossed. When there is sufficient available rotor geometry in the soup of available matter, life is the point of geometric algebra's rotor evolution, not an accident. It is geometry compelled. Next slide, please. I had a fun experience rendering this one. I instructed the physics observatory here to take a human being and assess the interflection density geometry with, again, only the basic matter bulk constitution of a human body. Interflection geometry dissolves the boundaries between atoms in a body that's coherent. In effect, you've got a body of geometric algebra rotors that are describing the energy momentum strata that is you. That is your potentum body in general terms, quite literally. It's not an illustration, folks. Those are the density lines that form from your tissues in aggregate. It was an astonishing thing to see that rendering a few weeks ago for the first time. We can then venture off into just for a few moments the implications for our thoughts about what this means for the nature of consciousness, what it means for the nature of ourselves as beings. Consciousness is, in my opinion, at this juncture, ordered flux. I might go so far as to say that potentum is consciousness fundamentally. It's sensation, raw. And as the structures build in layers of reciprofluxion, in orders of reciprofluxion upon reciprofluxion, each order of being, it certainly begs for a more spiritual interpretation of our ontology at its core, which we can talk about in the Q&A section if you'd like. Humanity is thus viewable as a superconsciousness as a species, families of human beings as reciprofluxion loops, cultures as extended concepts of sensons with their own durations, and civilization as cosmos remembering itself. Implication, our systems of governance, ethics, and culture are not merely constructs. They are coherence engineering. And reciprocity, reciprocal induction, is not only a moral obligation, but physical law. Societies that can begin to think this way over time, I think, will endure and be far more vital than if we remain in the dark on these fundamental aspects of our nature. Let me continue on to where things go in the end, the future of the universe. And I have a surprise for you here too. The evolution of stellar systems has long been understood to involve so-called neutron stars, pulsars, neutron stars, and ultimately black holes. In the conventional astrophysical narrative, massive stars die in violent deaths. When fusion no longer sustains equilibrium, gravity takes over, crushing the star's core. The result may be a neutron star, a city-sized sphere with density beyond imagination. Can you go to the next slide, please? Let's catch up. There we go. This is a fascinating image. My friends, that is the interflection view of a neutron star, literally. The lattice that you see there, that structure, again, is not illustrative. That is the actual rotor density volumetrically rendered in a 3D pixel physics space, a rotor space. That's density geometry of geometric algebra rotors solely. Wow. Those lines are real, in other words. Now, of course, they'll be shrouded by all sorts of material that is emission and distributed in many layers in many ways and spinning rapidly. But that's the basic structure you should expect to see when we can finally resolve what neutron stars look like with optical instruments through telescopic systems. Here's the interesting thing. What happens when the potentum density of a neutron star crosses a certain threshold, which can be defined here? The neutron star introverts, experiences an outside-in inversion and flips into what we would call a black hole, which can be shown as well. Let me just describe how that happens. A neutron star is the maximum packing of sensons in a cube, what turns out to be in the rotor geometric algebra calculations, computation of the packing of matter at that density of geometric algebra rotors occupy a cube octahedral symmetry, an octahedron with cube vertices oriented at a 45-degree angle to the octahedron. That's the basic structure that the geometric algebra rotors must take under extreme density conditions. Protons and electrons merge into neutrons. Effectively, you can think of a neutron as an ultra compressed hydrogen atom that becomes a stabilizer, spacer, if you will, in the platonic lattice, the shelled platonic nested structure that is the atom, the periodic table. Each neutron is a bound closure of geometric algebra in that highly dense state. And each swirl of impulse, J, currents stabilize the clocks of duration, stabilize the loops of interflection. The result is a staggering persistence. Pulsars spin with millisecond precision. Their pulses keep time across galaxies. And this is sense-on coherence under extreme pressure, extreme precision. An introverted neutron star is the true nature of a black hole we have determined. It is not a singularity, but an inversion of reciprofluxion. Excrofluxion flips fully into introfluxion as the matter folds in on itself in an abrupt event. Optical evidence supports this. Accretion disks around black holes blaze with light, not silence. Jets extend thousands of light years, channeling flux into coherent beams. These are not emissions from nothing. They are potentum flows reconfigured by inversion. Gravitational waves recorded by LIGO are not chaos, but quantized chirps, the echoes of sense-on lattices reordering their duration folds. I could go into many other examples, but let me conclude with the implication. A collapse is generative. Neutron stars represent maximum ordinary closure, and black holes represent the inversion of that, recycling sensons into new coherence. Quasars physically associated with galaxies, as Haltenarp observed, are the offspring of this inversion. Cosmology, therefore, regains continuity. No singularities, only deeper order. For engineering, the whispers of great possibilities emerge. If inversion can be understood, controlled, even, inversion might be harnessed. Reactors that recycle matter into flux, engines that bend inertia by flipping the interflection state of matter, and collapse becomes not death, but a doorway. Next slide, please. I'm not going to go into this detail because I'd like to get on to the next part of my presentation quickly. But let me take you, if I may, to the general cosmosia hypothesis. I've been talking about Potentum and the realization that space is not only not empty, and not only is it ZPE, but it is not stochastic in its raw nature. It is structured, and that geometry is now, I believe, thoroughly understood. And it will be a great pleasure to take this realization and apply it for society's benefit writ large, as I will discuss in the next hour or the next 45 minutes or so. But I'd like to just show you one last image here. I've been working on my lingo here and trying to formulate neologisms that are fitting for this new understanding of how we can interpret physics and reality. I've come up with the word cosmosia to describe the hydrodynamically isomorphic view of the Potentum medium as an ocean, and seeing ourselves and cosmic bodies much more like a marine ecosystem of living beings at all scales, coherently. And cosmosia is my appellation for that. But this comes together. Can I ask you to move to the next slide, please? Here we go. Now here's an enjoyable interflection density topograph. You see there depictions of an ocean, looks like an ocean, a tree, some flora, and clouds and a mountain and sun. Those are actually geometric algebra renderings of the canonical forms that those bodies do take literally in physics detail. The concept of geometric algebra in this presentation reveals that the geometric ideals that you see depicted here, again, purely geometric algebra renders, not skewed as to anything but the phase of the matter involved and its density. The shapes from the tree to the water, to the mountain, to the clouds, and to the star are geometric algebra only shapes. Those are the shapes of successful closures in our everyday life. You're looking at geometric algebra ideals that are in the math as the morphologies that clouds tend to seek, that mountains tend to become, that plants want to do because they have to, given the opportunity. That's how they go. And the same for water and for any stellar body. It's just astonishing to see the holism and the inner soulful sensation that you get in looking at how geometric algebra naturally, rotor algebra naturally congregates in these forms, my friends. It's just truly astonishing. The implication of all this, my friends, is that cosmology and physics are reborn. Could you go to the next slide, please? And the implications are sweeping for all of us as people, individuals, and how we look at ourselves and how we look at each other, how we look at the big picture and the small pictures too. But this picture here is the subject of the next 30 minutes or so. I will take a 3 or 4 minute break to just queue everything up properly, and then I'll continue with the aerospace implications and the plan ahead. It's robust, and we're ready to go, finally.
Awesome.
And I'll give you a status on the experimental trajectory, where we stand, and some extraordinary news about how close we are to seeing every aspect of this illustration.
Joe, this is wonderful. This is absolutely
I'll be back in just a few moments, please. Thank you.
Okay, so Joe is actually queuing up everything else. So what I'm going to do is I'm going to take down this slide deck, and he has slide deck number 2, making Star Trek real, the HoloWim aerospace architecture. So again, I am overjoyed to finally have the legendary Joe Firmage on APEC. He has been a keystone figure in this area for so long. And so to finally have him present here is just absolutely wonderful. Now, we did stake out 2 hours for Joe to present. I am hoping that he is able to push through this within that time. If not, I will ask Mike and the other folks if they're able to potentially push back just a little bit. And actually, I am going to double check my schedule.
Tim,
again.
can you hear me?
Yeah, Joe, perfect. Yeah, Joe, are you still there?
Tim, can you hear me?
Yes, I can. Yeah, okay, and hopefully that was his mic having issues and not mine. Let me bring Joel in really quick. Joel, can you hear me okay?
Yes, I can hear you. It's a very great presentation.
Yeah,
I like it very much so far.
I'm super excited.
I would give some little positive feedback on the wording. For example, this entropy, that is exactly Burkhardt-Heim's syntropy, right? So maybe a wording change here
I'm back.
would be
I'm
welcome.
sorry, I was off for just a moment.
Oh, that's okay. Well, Joel, let me take you back out then,
Yes,
and
please go.
we'll push through it. Thank you, sir. Okay, Joe, how are you doing?
I'm doing fine.
Perfect. You know what?
Yeah.
So while you were taking a break, I was just
Yeah.
remarking how it's absolutely wonderful to have you presenting at APEC. And so again, you have about half an hour left. If you do run over, we can try and squeeze things through. So we'll see how it all works.
Okay, thank you. There's so much more detail for 25 years of work, hundreds of people involved in all this stuff, stories to tell beyond my time allocation here. But I wanted to start this section out by telling you something from my heart. I can't believe how fortunate I am, how lucky I am to be here with you today, because I can tell you with clarity, with confidence, that every single thing you see in that illustration, we now know exactly how to engineer, including gravitational lenses, the material in the skin of a craft, and from an inertial propeller to a gravitational dipole, basically a warp bubble, if you will. We know how to do this stuff now as a result of the clarity that the physics have brought here. I will not go into the details of blueprints in this presentation, but I will tender and volunteer to my colleagues across the industry and in government. Uh, I'm very serious about that statement. We are ready, and I could not have said that merely months ago. I have been startled and gratefully so, as I said, at the clarity that this physics observatory has given us into material science and all the aspects that are involved in making that depiction real. I'd like to go into some detail on that right now, but in the time frame we have left, I'll try to get through quickly. Let me step through, and I'd like to talk about energy and then two phases of propulsion, and leave it at that for now. Okay, let's go to slide 2. And next one. You guys can read about the history later. How do we do the impossible? Okay, energy, propulsion, materials. How do we do the impossible here? Power without fuel. The fuel model is so ingrained that any alternative appears to, violate your morals as a scientist. That's not quite the case, again, because we have successfully reformulated the second law of thermodynamics to include a precise and accessible understanding of what Potentum does to balance that energy equation exactly. And it has everything to do with the basically taking geometric order, disorder out of the medium and ordering that, creating a disentropic function that effectively lowers the heat bath floor for equations of balancing out energy conservation in favor of the opportunity to create a reliable, if modest, stream of excess current per cycle of a sense on a potentum in some kind of structured circuit. The details of that I will not share today. However, I will share the physics principles promptly here. How the device for energy generation can actually work. An energy tap, as we proposed, is a phased array of field elements magneto-electronic mechanical transducers, if you will, driven a generative motor driven by a control law that phase locks to ambient or seated potentum modes, phase locking to ambient modes. By advancing the phase where peaks and retarding them on extroversion peaks and retarding them where introversion returns. Another way of saying that might be more accessible here by creating a time asymmetric mechanical circuit, electromagnetic circuit, where the duration of assistance is extended beyond the duration of resistance. Capitalizing on that geometrically is possible and is now understood. That is one of the central initiatives internal to the Academy at this time. We do, in fact, have a successful demonstration energy producing generator whose mechanism may be familiar to some of you out there. It was originally called the Marinov motor when we studied it 25 years ago in my laboratories in California. We actually built a couple of them, and we could never figure out what the assertions were all about. But we could not deny the fact that, properly engineered, there were some real interesting anomalies in that work that just simply worked, and we couldn't figure out the theory. Well, now we have with Potentum physics. It is now understood, and I would be happy to divulge more of that in appropriate context for those who are interested strategically. The details of this I will leave for those of you who are interested. And Tim, I will authorize you, if you don't mind, to distribute my speaking notes for the full address of the 2 hours that I was theoretically to give, because there's a lot of detail in there that I think our audience may find useful. And since I made the lecture here for the purposes of disclosure, you are welcome to share that with audience members, that which I've sent you, if you will, the lecture notes. But the details are pretty interesting. Let me just describe the device. I'd like you to go now from energy to energy is sufficiently detailed that the descriptions are available. I'd like you guys to look at the papers and query me offline on further information on the as we refer to it, the reluctance generator. Let's move on to the one that I know holds the greatest fascination for the for this crew. Okay, APEC is all about propulsion, and let me describe what we have done in the past 20 years on two aspects of the propulsion challenge. The first is the challenge of creating an inertial propeller. How do we create a propulsion system that does not eject propellant, that can exist in an electromechanical, or at least a magneto-electrodynamic sense, mechanically propel, and I will save the gravitational field engineering for the next slide in just a moment. But let's stay on this topic for just a minute. Next slide, please. In the early 2000s, in my research across the field, I came across repeated mysteries that circled around precession and gyroscopic the reason and the nature of gyroscopic precession was mystifying, and rightly so. I mean, the great physicist teacher Feynman characterized the opacity, the unexplainability of why a spinning gyro top on the kitchen floor can lean over in gravity, where its center of matter is clearly off vertical. Why? If you're just to somehow box up that gyro and weren't even to know it was spinning, how the freak does a center of matter lean over in gravity? And I came up with the explanational framework that we began to investigate. My assertion was that in a spinning gyro, the center of matter projects to the tip of the axle on the floor, if you wish, simple terms, projects the center of mass away from the center of matter, like a lens. Just think about that example. In a precessing gyro, where is the center of matter? And where is the center of mass reaction in that system when it's spinning? The center of mass is at the tip point on the kitchen floor of a simple toy. But the center of matter remains where it is, regardless of the spinning, regardless of whether it's spinning or not. That was a profound, simple realization that I intended to investigate, and I did. So 9 generations of experiments later, and setting aside public controversies that were ill-informed and premature and injudicious to the contrary, we have demonstrated multiple 100 pounds of repeatable thrust that's unidirectionally, generally speaking, without the ejection of propellant of a 65-pound, 13-inch cube containing 2 gyros, a unidirectional thrust measured in the hundreds of pounds with the right optimization of relative RPMs of a twin gyro system in that cube, repeatedly, and has been repeated in 4 generations of multi-million-dollar scale since that first observation in 2009. By 2019, our 9th generation test device was recording unidirectional lift in accordance with the formulas that we have since now determined. And suffice to say that I have made a proposal as part of the financial package that I'm presenting to industry and government beginning next week for the first time at scale, a testing trajectory for the acceleromotor, the inverse of an accelerometer. And it really goes like this, folks, to see how really simple philosophically the assertion really is. Why is it that we use gyroscopes in all media, space, sea, air, whether there's an atmosphere or not, whether you're in gravity or not? A triaxial gyro running can detect inertial motion, inertial acceleration, that is. The angles between the spinning gyros tilt with respect to each other in XYZ. That's how we measure inertial acceleration if we're blinded. And it works in space too. So, as a hardcore Newtonian myself, that which we can detect, we ought to be able to cause. We can figure it out. So if an accelerometer can react physically to acceleration in space, why can't its inversion, the powered change of relative spin planes between the spinning triaxial, why can't it cause a back reaction if we force from within the spin planes to adjust? will it not back react on the medium and therefore the surrounding airframe? And the answer is it does. And the specific equations and the modeling of that have only in the last year been resolved to the point of clarity. And it also comes back, of course, to the geometric algebra becoming mature enough and at hand in computational platforms that we could actually run the geometric algebra and explore these eventualities in physical systems. And I'm just delighted to report that we have a clear pathway now to scale what we observed in the laboratory from 2009 through 9 generations to 2019, and absent the break that society took during COVID and such, we're basically ready to go. And I'll be discussing that with my financial partners and government partners this coming week and beyond. The acceleromotor is the baby step, but a big one for the equivalent of an impulse drive to make Star Trek real. Let's go to the next one, please. And let's talk about matter. And this gets into the general domain of where we're going to be able to generate gravitational fields. But effectively, a new degree of femtoscale engineering of material science is now possible, definitively so, abruptly so, just in the past quarter. As a result of the resolution of the Origami Observatory, the Physics Observatory, I can render at will any camera position with femtoscale resolution from the interior of an iron nucleus to a supercluster with a physics camera that has a flawless record. I'm proud to say. It's amazing to say. It sounds unspeakably arrogant to say, but I have yet to see it fail in terms of predicting and then rendering what we observe in nature. And so the concept of creating a potentum dipole by the emission of structured interflection fields through specifically tuned materials, such as the skin of a craft, being an ideal candidate to attenuate the volumetric interflection geometry and create a geometric buoyancy in surrounding potentum is literally what gravitation is by its intrinsic nature, and how it can be modified under engineering regimes. I will have the opportunity to be addressing this in some detail next month. On October 26th, I have planned a substantial public disclosure occurring, in which I will be taking the next step of public visibility and inspectability of the physics of gravity attenuation as achievable by the specifically designed engineering of interflection fields with the tuning of specific material lattices, material structures. I will also give a further hint that as we rise in Z on the periodic table into the range just above where we're currently able to routinely create synthetic matter,
Joe, are you back with me? We lost you for a sec. Okay. And again, Joe is on his mobile, so he will be back and I will add him right back in. Okay, I'm going to bring you guys in for just a sec. So what do you think so far? We're waiting on Joe.
I think he got censored.
Well, he's on a mobile. You know, I am beginning to wonder. We've got Brendan with us too, and I'll take you guys back out if he's able to make it back in. So it could be his mobile
You want
phone.
my opinion? He's getting too close to the truth.
There you go. I'm beginning to
does
wonder
he have
if
anything that works? I mean, does he have anything to show? And the claims are amazing. He's got a whole new set of words for everything. But
yeah,
well,
you know,
does he have anything that he can
the
show any
gyros,
data?
I need to talk to him. He's talking about gyros. Boeing's been working with him years ago for propulsion. I got a model sitting right in my lab here.
So he's talking about doing. He just mentioned doing a press conference, right? Later, you know. And let me see. It's 1:49. So let me see. I would say maybe if he doesn't make it back in, we'll give him another couple of minutes. But in fact, let me take down that thing there. So I've got everybody in the room here. But yeah, I would say if he's not able to make it back in the next couple of minutes, we could just maybe we could go to Mike if Shiva isn't here. Shiva is going to present today too. And Drew, as far as what he's working on, I believe he does have some stuff that he's going to unveil next month. But he really just kind of called me out of the blue, and you know, Joe is, again, he's almost kind of a legendary figure in this area. He had a massive research group like 25 years ago now, right? So it's exciting to have him back. It's exciting to have him speak. I'll bring Jared in too.
So yeah, to me it sounds very great. He says a lot of the stuff that really excites me. A lot of the principles are familiar to me from Heim theory, and it's answering the right questions. If he can back this up with the full mathematical derivation and real working model, that's a different question. But on a first glimpse, it sounds great.
Yeah.
I now understand how people must have felt in my Heim presentation because of the terminology, right? And I would love to talk to him a little bit. For example, disentropy is like a double negative, so maybe just use syntropy as a word here. It's the same principle in Heim theory, and also his reciprofluxion. This is like telecentric stuff in Heim theory. So I can already map a lot of his stuff, and maybe we can talk a little bit of the terminology, but that he came up, I think, completely not knowing of Heim theory at all with the same concepts is to me a good sign. and that he mentioned geometric algebra so much is a very good sign to me, and I'm very excited to see. Already listening to the presentation, I looked up his papers, and there's some more mathematical depths in the papers than in the presentation, right? That's not the full depth that I'm looking for, but I hope he will unveil more over time.
Well,
so very exciting presentation.
And Joel, we're at 151. Before we go further, I think just so that we don't forget, we should all put our hands together and give an enormous applause to Mr. Joe Firmage. And you know what? If he makes it back, we'll do more clapping, but I'm excited about what he's done so far. This was a massive presentation. He has been incredibly quiet, as he said, for over a decade. And so it's awesome to see him starting to take a more active role in the community. He's happy to come back and present more in the future at APEC. He mentioned doing some kind of a press conference as well, right? So my hope is that he's starting to roll stuff out, and like Drew's question about what does he physically have that works, that'll be answered as well as he starts to unveil more about what he's working with.
Yes, I'm really looking forward that you can send around the notes that he talked about, and I would really love to get his email address. I can send him maybe a short write-up about terminology. And yeah,
and Shiva's here.
I don't have any sound.
Oh, Shiva, you don't have sound yet?
There we go. Okay.
Okay.
I was gonna try to shave real quick. I stayed up all night.
Nope. It's too late now, my friend.
All
Too late now.
right.
Yeah. So Joe Firmage actually just did a 2-hour presentation. I'm really excited. We're just wrapping things up there. Joe, I think he lost power. He's on his mobile. And so he kind of disappeared on us, but we can have him back to present more, or if he's able to make it back in later today, that's totally cool. One of the things I've been wondering about, I'm getting little bounces in the network. I actually switched providers. I went from Xfinity over to the local fiber provider, and I'm still getting some bounces. There's a part of me that wonders if all of this AI usage on the internet now is starting to strain cloud providers. I don't know.
It also affects the power grid, sir. Like it's not good.
Yeah, like I'm getting internet bounces, it's like bouncing internet. I'm like, what is this, like 1995? But so yeah, it's interesting. It's interesting. I've had 3 short bounces during this presentation so far. So
yeah,
and you don't know if they're going to move it into your neighborhood, because the companies are using shell companies. The big data companies are using shell companies to introduce themselves to communities. And so you might have one move in around the corner and you don't even know it until you have to start having internet or power interruption.
And maybe one short sentence to the presentation we just heard. So to get geometric disorder out of the Potentum, which is the ordered vacuum substrate in his theory, right? This also sounds great to me. This is exactly the approach that Burkhard Heim went into for his contrabarrie device. So I think one of the second last slide was basically Burkhard Heim's idea for contrabarrie, and the last slide he showed was basically Zafati's idea for metamaterials to manipulate space-time engineering. So very exciting stuff.
Yeah. And Joel, one of the things that you mentioned, and I think that this is really important, and hopefully APEC helps, but just in general, different terms, different terminology by different people and different research paths, right?
Yes.
And like you just described him circling concepts that are being explored by other people. But then if framing all of those in unique terms, it makes it so difficult to work together, right? So that's something I think over time that just gets better,
Yeah, but we have to communicate to get better in that, right? So it's very good to have the conference, and we need to have a follow-up and then come to an agreement about terminology for certain ideas, right?
I actually have, you know what? I don't think I have it anymore. I had on, where is it? ChatGPT had core terms. Yeah, that was kind of interesting. For anti-gravity, gravity control, gravity modification, gravity manipulation. I thought that was, it went through and found, you know, how do these land? Which ones will get you in the most trouble with the scientific community? And so apparently ChatGPT said, don't say anti-gravity unless it's like science fiction. It said use gravity modification. So that is the, just in case you guys are wondering, according to
engineering.
According to our robot masters, gravity modification is that the best one? Yes. Yes, it said, yeah.
The problem is that we don't have a fixed definition of the word, right? So people have different definition for anti-gravity. So for example, to Jack Zafati, this is like a gravity shielding idea, but to other people, it's a totally different concept, but they use the same word for different concepts. So miscommunication happens and people don't understand each other and get angry because they say, yeah, this is completely nonsense and disproven. And they
Oh, we lost Joel now.
We lost
man,
Joel.
they're coming after all of us.
I'm back. I also I have internet bumps. It's like 5 to 10 seconds. It happened
I am
multiple
getting
times
those
this week.
too. I'm getting those too. I think what it is all of this additional load from AI. I think it's starting to strain a lot of these network providers. I think it's straining the cloud.
Could also be the activity of the sun. It's been just putting out huge gouts of plasma more and more. It's way more active than it's supposed to be right this year.
Okay, well, and it looks like Joe isn't back with us yet. So we've got 2 minutes left, and then I want to go to Shiva. Shiva, I'm so excited to have you back. Oh, okay, there is Joe. Let me bring Joe back in.
I'm sorry for that, my friends. You know, Murphy's Law and all that.
No, that's
but
okay. Well, Joe,
the Wi-Fi in this hotel crapped out on me. So
we're 2 minutes
Or
from
if you work at the
Shiva's
CIA or what?
presentation. But what I do want to do is, if it's okay, again, let's put our hands together and give Mr. Joe Firmage an enormous applause. And Joe, I am so excited that after being quiet for so long, that you're starting to discuss these things. You have an upcoming presentation in a month, you said, right?
Yes, October 26th is a big reveal. It'll take a few more weeks for us to get our house in order to scale up to the response dynamic that is obviously needed here. So I encourage everybody to visit my site and follow me on LinkedIn. LinkedIn is my effective virtual office.
And can I get your website URL again?
Yeah, it's josephfirmage.com.
Okay, and you know what? I'm gonna put that up right now. Here we go. Okay.
Here's where we're at, folks. We have successfully pointed our observatory at physics, chemistry, and biology and cosmology so far. And I have announced the availability of the Origami Observatory for third-party collaborations. Engagements can range from the simple of requesting some observatory attention to zoom in on a particular material, a particular, just you name it. Tell me where to position the observatory camera, from a nucleus of the iron atom to a supercluster and everything in between, and you'll see where we're able to go right now.
Okay, and Joe, so I put your website up. I'm going to drop a link in chat. It's josephfirmage.com. I highlighted these for people to take a look. It's got information about you. It has information about your research, really detailed PDF format stuff.
Yeah,
excuse me.
This is really groundbreaking science, and I'm grateful for the opportunity for the first time to start sharing it with this group.
Yeah. So josephfirmage.com. And again, Joe, I am overjoyed to have you with us today. So let me stop sharing on that, and I'm going to drop that link in. Okay. There we go. And Joe, so we are actually, it's 2:00 now. So Shiva is going to do a presentation for us on fluid dynamics model of physics. So let me thank you one more time for presenting for us. And I would love to have you back in the future, sir.
I will be ready and willing. I'm all ears, and I'm really excited to see the presentations to follow. You've got a great group of people to present today, and so it's a privilege and an honor to be in such wise company.
Absolutely. Well, thank you again.
Okay, thank you, guys.
All right. Well, I'm gonna have to
Shiva. Thank you. Okay.
I'm gonna have to apologize for pushing it too far. Like you try to judge how much research to do before you put it into a presentation. Well, I way overdid the research and underdid the presentation. So I've just got I've got bullet points on a
that's totally cool. And let me see this. Yeah, this one's yours. Okay.
Yep.
Yeah, I'm super excited to have you back. I love the intuitive nature of the model that you've described. And I feel like a lot of folks kind of get lost. And so that's why I keep inviting you back to pound it into their heads and say, okay, you guys get this matters, right? But some of the explanations you've done in the past, especially in terms of like quantum uncertainty and things like that, and how those can be modeled with fluid dynamics, are just groundbreaking, right? I think it's like drinking from the fire hose. It's so much and it's so brilliant. So thank you.
Well, thank you. That's a great introduction. I really appreciate it. So doing something a little different today. So basically, how I do things is always kind of coming at things from a perspective of looking at history and some of the questions that people have been having recently. And like I said, doing something a little different. I'm going to kind of show through history how it is that UAP secrecy is atomic. Energy secrecy is ether secrecy, and so basically, you have all of these hearings and things that have been going on, and people testifying that basically we've got these craft that have crashed, and there's been reverse engineering, and there's partial success in this reverse engineering. And so what I'm going to do is tell you the story today as quickly as I can, because I have got many pages here, and I have not even guessed at how long it's going to take me to present all of this information. So I'm going to try to do a speed run, but we're going to start with the very early history, and we're going to go through a few different things. I'm going to try to bring some of the stuff to the top right at first here. So let me look at my notes, because I actually, like I said, I was up all night, unfortunately, because I way underestimated how difficult it would be to take all this information that I already researched and put it all together into something that could kind of tell a story. So there's if some of you have kept up with some of the commentators and things like that are in the UAP and alternative physics circles, like one of the commentators that I appreciate is Eric Weinstein, when he's speaking specifically about that topic. And like he points out that he believes that there was various things that to him indicated that there was a disinformation campaign in the 70s, and that is part of, like, he specifically talks about string theory as part of a disinfo campaign, and I would like to add some to that, but we're going to get to that in a minute. So there's a few different questions that you kind of have to ask yourself about the history of physics, because there is, once you start digging, and you're not at the Wikipedia level of history, but way deeper than that, and actually looking at original source documents, and instead of secondary retellings, you end up finding out there's some real deep weirdness in our history that kind of can, if we're going to tell the story of, who's hiding what, when were they hiding it, how did they know, where did they get it, and all of that UAP history, and anti-gravity history, and all of these things that are all one single history. then you kind of have to start looking at some weirdnesses. And one of them, of course, is that why did Einstein say space without ether is unthinkable when he knew of space-time? So he wasn't referring to space-time. He was working very, specifically with space-time in 1950. So Einstein said this in 1920. It's 15 years after special relativity, 5 years after general relativity. So why did Schrodinger say that he regretted having anything to do with quantum physics when we know the Schrodinger equation is like the heart of quantum physics, right? But we're told the opposite, that Einstein, of course, was he's the the one who got rid of the ether, and we're told that Schrodinger, actually, I don't think they really teach this anymore, because my research stage started like 20 years ago, and 20 years ago, anytime people talked about Schrodinger's cat, they were like, oh yeah, there's this great demonstration that proves how weird quantum physics is, whereas Schrodinger was specifically saying, no, it can't be like this. I'm telling you, it's not like this. Kitty, stop. And let me demonstrate how bad this idea is. And so once again, it's a complete flip of what the original author, original person who developed these central ideas told us. So we end up getting the exact opposite. Then there's a central character that's really going to be the apex of this story. That's David Bohm. And so why did he write the book on the Copenhagen interpretation in 1951? It's published, and then a month later he walks in, I'll tell you the story in a little more detail here in just a moment, but he walks down, picks a manuscript out of his desk drawer, obviously, and sends it in to completely demolish the book that he just printed 1 month earlier. How did that end up happening? Why was he completely against Copenhagen? Whereas that book, by the way, from 1951 onwards, it dominated university teaching on Copenhagen interpretation. And we're going to get into Copenhagen interpretation being a very apt tool. So then another question is, why did Bell talk about Lorentzian ether? I've got a few different quotes that I've shared a number of times, but I don't have a lot of time to do this and a whole lot of information to give you. So, but basically, Bell specifically talked about the solution being relativity as it was before Einstein, which a lot of people do not realize that time dilation, length contraction, those things that most people topically know about relativity, those existed for 10 and 15 years. Length contraction for 15 years, time dilation for 10 years before special relativity. Special relativity was Einstein's extension of Lorentz's kinematics, and he was doing electrodynamics, and Poincaré also did the same thing. He extended Lorentz's kinematics, which you associate with relativity, into the electrodynamics. So a lot of times people they're just not understanding that relativity, all of the relativistic mechanics, the specific calculations that are the central beating heart of relativity, were developed specifically and entirely to describe ether theory. So then why did the Nobel, I didn't finish on Bell. So Bell inequalities, everybody's, whenever you hear about Bell inequalities, well, Bell inequalities, when you start digging in there, that's the proof that the world is actually spooky and weird at the bottom level. That's at least what we're told. However, when you dig into John Stuart Bell's writings, he is constantly talking about, first of all, David Bohm, who is what he was intending to prove was Bohm's work, and also very specifically spent his life into the 80s trying to dissuade people from the interpretation that they were taking from Bell inequalities. Then we have to go fast forward to 2022 Nobel Prize for Bell inequalities experiments, and that was so why now do we have this this given and people talking about it as though, well, here we go, we're given a Nobel Prize for proving that the world is spooky underneath the surface. Except that is the commentary around it is completely different than what the scientists themselves actually intend. And why is there this consistent flipping to the exact opposite all throughout history of what the initial scientists intended versus what story you are hearing? So on August 1st, Anton Zeilinger just published a paper basically completely ripping the heart out of anything Copenhagen interpretation, including the decoherence path that that it was a new patch to try to keep Copenhagen alive. So let's start all the way back at the beginning, and I'm going to try to rush through the ether history because a lot of people people have probably heard me do some of this before. Once again, don't have a terrible amount of time, but let's start at the very beginning where Fresnel is the one who really starts ether theory up as a science in the 1800s, and he specifically gives this idea of how to think about refraction in terms of ether. Now, I mean, it was already still being used, like for instance, stellar aberration, which we are taught as proof is evidence against ether, was specifically evidence for ether, and you'll find that story is constant. There's always a flipping of the narrative. But what he ends up giving is some mathematics around it, and what's very interesting is that he predicts that there is going to be this partial ether drag. So I'm going to try to tell you that this is the very start of ether is actually where something was a arbitrary decision that kind of poisoned the well accidentally from that point forward, and that is there's two ways in which you can change the speed of a wave to be slower, and that is you can either increase density or you can reduce rigidity. And I'm going to tell you right now that the solution is not what Fresnel thought, which was to increase density, but instead to reduce rigidity. And when you start thinking in terms of reduced rigidity instead of increased density, then what you have is it wipes out a huge number of problems with ether theory. And it's just two parts of the equation. You could pick one or the other, the top or the bottom. He just happened to pick the wrong one, and that kind of poisoned the well from that point forward. So I'm going to kind of rely on that, and I'm going to speed up here in just a minute, but I still need to really get to the heart of the start of ether theory, and so that you understand exactly how we can still be using it and what changes to it have occurred over a very long period of time. So Fresnel predicts the ether drag, and then Fizeau's experiment in 1851 then specifically proves it exactly. Now, the retroactive history of that is after relativity, they're like, well, that's just the relativistic addition formula. However, what we end up finding out is both Fresnel's coefficient of ether drag, which is the partial ether drag, and the velocity addition formula, and in fluid dynamics, what happens when sound, so in other words, waves, travel through a bubbly medium and the bubbles are in motion, what happens is mathematically equivalent to those other two. So it is direct mathematical equivalence, which of course then matches the idea that atoms are localized areas of reduced rigidity, not increased density. So that was where Fresnel went wrong. And then from that point forward, we're going to just go with that idea that basically atoms are going to be reduced rigidity through vortical motion. This is a well-known aspect of especially how superfluids work. So now let's go quickly through the beginning of ether history. So you have Maxwell develops electromagnetic theory using fluid mechanical models. Then there's the Michelson-Morley null. And that, actually, when we look at it from the perspective of Fresnel's work and this idea that I've just told you, which is that it's, whenever you have sound going through bubbles and looking at atoms as bubbles in the ether is a very simple way of seeing it. Then what you end up computing from the actual data of the original 1887 Michelson, when you go back to it, is it actually gives a measurement of the ether wind of 370 kilometers per second, matching the CMB calculation that we have today. And that is a very complex thing I will go over with anybody who wants to, but just take it for what it is at the moment, and let's continue forward. So 1889, Fitzgerald, he proposes the contraction factor, which, if any of you are familiar, that's going to be the central calculation of relativity. It tells us how much things are shortened, how much time is dilated, and that's in 1889, like I said, 15 years before special relativity. So then in 1890, basically, Lord Kelvin publishes on a gyrostatic adynamic constitution for ether, and this proves McCullough's rotational ether is mechanically feasible. So I actually skipped over something up here in 1839. McCullough was kind of forgotten for a while, but he is actually the basis of the field concept, and this was a rotational ether. Now, people at the time, they didn't like the idea of rotational elasticity because there was no physical model of it. However, Kelvin then proved a physical model of it, that it was physically rational, and at the same time time, there were these people called the Maxwellians who were working on trying to resolve some of the leftovers of Maxwell's theory, because Maxwell started with vector calculus, then he's using quaternions, and a lot of people they hated quaternions, and so eventually this group of people kind of put the finishing touches on Maxwellian theory, and that's one of the things that was very important to those developments. So then in 1905, he said one of the things that is people misread because of the filter of history is that in 1905, Einstein was not initially rejecting the ether in that paper. He was showing that there's a mathematical shortcut, because all the other people who were dealing with the ether were dealing with both possible perspectives of time dilation, which means, in other words, if I'm slowed down, then I see you as sped up, but then in return, you don't see the same thing because you're faster than me. There's an opposite sort of perspective that without enough sleep, I'm going to skip over, continuing to explain right here, right now. But anyway, so they had to keep up with these two different perspectives. And Einstein said, what are you doing all this, a bunch of extra keeping up with all these details? And because basically what they were doing was describing the specific consequences of what was intentionally a mathematical illusion. In other words, what they thought is that things are shortening up just enough to deal with the fact that light would have to go catty corner in one direction, then try to really slowly go upstream, with an ether wind, and then quickly go back downstream. All of that math actually comes to exactly what Fitzgerald proposed there. That particular mathematics is, basically it's Pythagorean theorem for an object in motion through a medium. So in other words, it is that calculation is a calculation of how a medium alters waves going through it when you are measuring it in motion, and that object shortens and creates an illusion. So that's what relativity started as, a description of an illusion by Lorentz, Larmor, and that whole group, until 1905, when Einstein goes, okay, yeah, you don't need to keep up with all that stuff, man. There's just this quick calculation of the kinematics, and you can just forget about the other perspective and just believe all the perspectives are one. Now let me work on what I care about, which is the electrodynamical part. Here's the kinematical part, blah, blah, blah. And so people don't understand it's in two parts. So that's very important to understand that he was not adding the Lorentzian part. He was not saying he was adding the Lorentzian part. And what most people know about relativity is the Lorentzian part. So then let's continue forward from there. So in 1908, Minkowski publishes the space-time theory, declaring space by itself and time by itself are doomed to fade away in mere shadows. I actually believe it was 1907. I got some help with this document, and I thought that he first put it out elsewhere in 1907, but I'll have to look into that. Anyhow, it's a fundamental incompatibility with ether at this point. In other words, he is the one who adds the idea, which makes the relativity of Einstein be incompatible with ether. In other words, it starts out as a description of ether. Then what Minkowski adds, which Minkowski was Einstein's maths teacher, what he adds is something that makes it utterly, you cannot make the two work. You have to have a completely new worldview, and that is the conjoining of space and time, which assumes that light is not performing an illusion, but specifically light performs like no other wave has ever, like we've ever seen, and that basically the world is kind of wrapped around light. And so that is entirely Minkowski's idea. It is not Einstein's idea to wrap it that way. And he initially mocks the idea and says, well, since the mathematicians have entered the theory of relativity, I don't understand it myself anymore. So that was in 1908. He quips that. Then Minkowski suddenly has his appendix burst at like 40 years old, so a fairly young man. It's a very small community, devastates the community of scientists, and right after Einstein had just insulted him publicly, and so that's a big part of the reason why he ended up adopting it right after he had ridiculed it. And so then he does take on the idea of completely eliminating the ether, but he only does so for about 2 more years. Well, it was until around 1912. So there's another thing I'm going to point out here is that there is a character named Leonard in German physics. He was a Nobel Prize winner, and he's going to be important to the story a little bit later. But basically, in this letter in 1910, he actually mocks Leonard's work, which was on ether theory, to Leonard's direct. Somebody who was working directly for Leonard, and he calls it infantile idiocies, basically. Well, infantile in one place, idiocies in another. And so he's fully on board with discarding the ether in 1910. However, by 1912, he's actually starting to return to the idea that I've got 5 different quotes of him saying we have to get rid of constancy. Basically, constancy has to be abandoned. Constancy doesn't work for anything having to do in gravity. And so after his publication, Max Abraham actually, publicly accuses him of abandoning his own theory. And so, and actually says that destroys relativity. It doesn't actually destroy relativity, but that was the polemic at the time in 1912. However, Einstein continues to talk about the need of generalization and that constancy has to be abandoned. Then in 1915, he suddenly starts working very closely with Hilbert. David Hilbert was a very, very close friend. And matter of fact, he talked about Minkowski in terms of love and closer than a brother. And so, of course, Hilbert was very continuing Minkowski's legacy was very central to Hilbert. And during 1915, there was a very, very close collaboration between Einstein and Hilbert that actually produced general relativity. So Einstein continues to make these comments about how you can't actually expect light to behave as a constant in any general relativity sense. However, without getting too much into this, basically that completely contradicts what it was that Minkowski was saying by joining space with time and basically creating this completely new worldview, which had absolutely no empirical basis, but was accepted because of his death. So then then there's an important set of events that start to happen around 1920. The Berlin Philharmonic is an event where a bunch of, so we already have, this is, right around end of World War I. And there is this anti-Einstein rally by this guy named Paul Whelan, who is this racist jerk. He has nothing to do with science. And he's just an anti-Semitic commentator and propagandist who denounces Einstein publicly, gets a bunch of people in the Berlin Philharmonic, and they're basically attacking Einstein because they're assholes. So Leonard and others, by the way, so Leonard is a very central figure here, were invited but refused to go. Then there's this basically after Einstein is attacked publicly like this, he then publishes what's called Mein Antwort in the Berlin Tageblatt, which is just one of the big newspapers of the day, about the Philharmonic meeting. However, he accidentally he conflates the intentions of these people who are completely separate from the scientists with the scientists, because he's already got a rivalry with Leonard, and basically ends up painting Leonard with the same brush of racism, and as well as the other people who are going to be at this debate, and all of Einstein's friends kind of jump his case in letters and say that was a terrible thing. You really shouldn't have done that. You must have really had your feelings hurt. But basically, it's unanimously kind of panned as a very, very bad move by all of Einstein's friends. Then the Bad-Nauheim debate actually occurs, and in this debate, it is entirely a scientific debate, but it's often reported in modern textbooks based upon Einstein's reaction to the Berlin Philharmonic, because sometimes things get lost in over time, and they kind of confuse things. So they just took Einstein's word for it that these guys were basing everything on racism instead of actually on their scientific problems with it. And indeed, here's the kicker: Leonard later does become a racist. He doesn't show any racist tendencies until about 1923 is the first time we actually see him starting to follow along with the rest of the German people who were pulled in by all the evil propaganda, etc. But at that time, he had actually not shown any, and so it was an unfortunate event. But what we end up finding is that there's actually this right after this lecture. So September 23rd is the Bode-Nummheim debate. Then on October 27th, Einstein does a lecture to the University of Leiden that can be summarized as space without ether is unthinkable. So basically what you have is that Leonard and others convince Einstein that you can't actually discard the ether. And then he writes a huge thing clarifying, saying, okay, I agree with that. You can't discard the ether. That was his 1920 lecture. So now that's kind of the end of relativistic physics history for the moment, and we're going to pick up on the quantum revolution. However, what we're going to show here is that there's been this undercurrent of fluid dynamics the entire time. Like, for instance, one of the things that was happening during the development of general relativity is Hilbert was using Mie's four-dimensional version of McCullough's ether. In other words, that is the tool that Hilbert used to help Einstein finalize general relativity. Was this something that was based upon ether theory? And so that's why this ether theory starts coming right back after people get over honoring Minkowski. But Minkowski's work is still now permanently injected into the narrative and into the way that things work. So we're going to look at, so in 1922, Erwin Madelung publishes his paper that basically shows that you can create a analogy of quantum physics, because this is the era of the quantum physics revolution. And he shows that you can actually have a continuous media and hydrodynamics be equivalent to quantum physics. And so this is a very big first step in actually understanding, that there are analogies. A lot of times today you might know about the ADS CFT, that they're equivalent there. Well, a lot of people have forgotten that there was hydrodynamics and quantum physics that was doing the exact same thing. And the reason why they've forgotten them, I think, will become clear as we get further along. So then we have in 23, Dayton Miller proves that with a certain set of experiments that basically that there is an ether wind. He gets exactly the same results as Michelson-Morley, which was not null, but gave a much smaller effect than they expected. And it can only be seen because it was in air. I can talk about that later, but that's just to kind of keep up with where we're going in the quantum revolution here. So you've got two different lines of development that are going on. So then in 1923, Heisenberg submits his doctoral thesis on stability and turbulence of fluid flow. This is important to understand that Heisenberg was trained as a fluid dynamicist, and his PhD advisor was Arnold Sommerfeld, who had worked very extensively on on relativity with Einstein. He actually did a lot of the mathematics and helped him out tremendously during this period. Einstein's constantly talking about Sommerfeld, and he's a very, very good friend. 24, De Broglie completes his thesis that gives basically he uses a very Lorentz and ether theory sort of version of relativity. Like, as I said, the ether theory version of relativity that was put forward by Lorentz Poincaré was widely considered to be, it's still today considered to be mathematically equivalent to Einstein's relativity. So in other words, understanding that there is this fluid dynamical version that is a split that is forgotten, that is completely still equivalent. So De Broglie actually uses the more ether theory version and waves, and then Schrödinger publishes his work that is the major finalization of what we think of as like finally quantum mechanics is real as a science, because what happens is Heisenberg and Bohr take Schrödinger's wave-based approach to repair what's called their matrix mechanics approach. And so they had this black box random stuff, and they didn't have a real way of categorizing the random decay and things like that. They just were trying to track the what was happening outside the black box of the atom, and and that's all they really wanted to comment on. However, Schrödinger's work then gives them a way of putting some handles on what's happening to this random, what appears to be random. So it's a huge godsend. However, this is where Schrödinger basically is very pissed off that they've appropriated his way of doing things to support a randomness based, in other words, a statistical approach, when he was completely a real, actual physical wave approach, which was based on Du Bois' work. So then in 1926, Madelung does another paper which shows that Schrödinger equation can be transformed into hydrodynamical equations. Heisenberg then submits a paper in 27 that is basically, this is just before the Solvay conference, and basically it kind of shifts the focus. So now what I'm going to tell you here is that there's Bohr and Heisenberg are the Copenhagen interpretation people. However, Bohr is basically the figurehead, and Heisenberg is sort of the man behind the scenes who is not, he has to kind of conform to what Bohr wants. So at the Solvay conference, there's they have these. That's where you get God does not play dice. Einstein is arguing against quantum physics because it's non-physical, and that's where that starts to happen. And so then Bohr replies, Einstein stopped telling God what to do. And so this is where those of you that know some about it actually know that this is where the Copenhagen interpretation kind of comes from, is the 1927 Solvay conference. So then that continues forward, and in 1931, Sommerfeld is the patriarch of German theory. So he is the PhD advisor to Heisenberg, and then he basically releases two key publications that are entirely based on field as a substance, and he really nails down something that is a substantive space and how that would work. So what I'm developing here is the understanding that a lot of people do not know, that German physics continued to be very strongly based in fluid dynamics all the way up until the until the fall of Nazi Germany. But so we're going to continue forward on this from here, because I do need to try to keep my time a little bit tighter. So basically, he's using a relativistic ether, and you can, stop and look at this again at some point. But then in 1932, Eugene Wigner introduces a phase space formulation of quantum mechanics. Now, this is where he is really taking some of the very important details that we've already had this start from Madelung. We already have a lot of the work of Sommerfeld, and then in Wigner, by treating it as a phase space formulation, he is now really given a lot of familiar handles to quantum theory, in a hydrodynamic viewpoint. So we've got now a really good working hydrodynamic version of quantum theory that's available to people of that time. Now, this is where we're going to start the beginning of UAP physics. Let me get a drink here. So. All right, as some of you may know, David Grush testified before Congress that the 1933 crash in Magenta, Italy, that was eventually stored in Vergiate, I think it is, Italy. This is one of the ones that he reported was actually one of the crash recoveries that he knows to be legitimate. And so we're going to use this as part of our narrative to try to understand where things are going and what's secret and why it's secret. So advanced saucer shape thing is recovered, and then you have the RS-33 that is eventually given to Marconi, and so there's this development on it that's starting to happen in Italy, and we can imagine that there might have been some level of espionage, etc., between Italy and Germany at the time, because they weren't fully yet allied. But we have a continued history of Heisenberg basically publishing papers that are that have a substantive space. He talks about things like that basically are descriptions of space being cavitated. In other words, like where there are openings in space. Constantly talking about a physical space is what Heisenberg is doing, while at the same time still supporting the matrix mechanics view, because it is really the only good handle we had on giving us information about these various events. In other words, he was not necessarily claiming the realism. That was Bohr who was claiming the realness of probabilistic interpretations. Heisenberg was simply claiming the value of these probabilistic interpretations. And so that it's important to understand these two people working together are associated and they're put together, but they're actually slightly different. So then we continue forward. Sommerfeld continues his work, and he's very, very clearly a ether theorist. And again, this is the same Sommerfeld that helped Einstein with general relativity, and is kind of the godfather of physics in Germany, because he's also responsible for what's known as the fine structure constant, which is still today something that is a very it's a very big deal to physicists. Like something Richard Feynman said is somebody you should put the fine structure. Any good physicist puts the fine structure constant up on their wall and like worries about it all the time because where did it come from? Well, Arnold Sommerfeld is where it came from, and Arnold Sommerfeld was very clearly an ether theorist. So then we let's see. We continue to look at some of Heisenberg's developments. EPR manuscript. Oh, then one of the things that happens in 1935 is the Einstein, Podolsky, and Rosen argument against Bohr, basically. In other words, they are trying to put forth this thing that's like, we can't have this interpretation of reality as probabilistic. Probability is a description. It is not a ontologically, feasible start. So, Einstein is saying, okay, quantum physics, works, but there's certain things that I don't think it's fully covering. In other words, I don't think it's a complete theory is what he's trying to say. And so one of the things that happens that's kind of a large event that shows the division between Heisenberg and Bohr is Heisenberg develops his own response to EPR and Bohr doesn't let him publish it. And so that is an interesting little tidbit that's very important to notice, that difference between Bohr and Heisenberg. Then in 35, we continue forward there. There's more debate about this. And 35, Schrödinger also proposes his famous cat thought experiment to mock Copenhagen, because he continues with Einstein and others to say, look, this is not a complete theory. You can't believe this, is because it's just nonsense. Madelung continues, and he finalizes his hydrodynamic version of quantum theory. And then there's a Heisenberg Euler paper that also, once again, continues to show these properties of a physical space, and the manipulation of that space is the basis for Heisenberg's theory making. In other words, it is about space-time engineering, except it isn't space-time. Because space-time is a very particular way of treating reality that and I continue to say space-time when I'm talking about the vacuum and ether. So then Tesla publishes his statement on the existence of a field of force can account for all the motions of the bodies as observed. And so Tesla is also on the side of trying to tell people there has to be an ether. Then here's a very important inflection point to this story, which is now. We mentioned the 33 crash. Why did I just only go over that? Because it wasn't until 1938, during Hitler's visit to Italy, that we are told that there is actually the transfer of information to the Nazi regime of the crash, crash material info. I don't think they actually. They specifically did not actually give them the crash material. They simply started sharing information with them. And then so in 1938, just weeks later, Heisenberg submits his paper defining a fundamental length, where he talks about these rips in the vacuum and specifically cavitation-like events. And so once again, he's talking about an engineerable vacuum. Then also in 1938, Heisenberg is cleared by the head of the SS of Stark's accusation of white Jews in science. So this is where racism in science actually saved us, because they were such jerks. They actually screwed up the science, and so they actually were attacking Heisenberg for his continued use of relativity. Heisenberg and Sommerfeld we're kind of under attack, and this is already, you know, now 33 is when the Nazis took control, so it was very dangerous for him. So Heisenberg's mother and Himmler's mother, the head of the SS, were friends. He actually asks through his mother to get investigated, and this investigation then exonerates him. Now, why is it that he can use relativity, which they're basically kind of, this is Stark and Lenard. Then now by this point in time, they're fully racist POS, and they're just they don't want anything to do with relativity, and so they're constantly, they want to go back to ether before relativity, but in other words before Lorentz, and even though they actually even talk about Lorentz, they still refuse to actually accept the importance of you know, relativity. And so this is where there's a division in the German science community on the point of relativity. And then specifically after this exoneration by the Secret Service, which basically, if you had anything that looked like you were sympathetic to anything Jewish, they immediately attack you by this point in time. We're talking about, this is right in the middle of, like, well, it's starting to be in the middle of some really horrific stuff that's going on, where things are getting worse and worse and worse in Germany at the time. So basically the reason why is because, of course, Heisenberg can show that he's actually working with a relativistic ether, which can appeal to the sensibilities of the Germans, who were okay with ether, not okay with relativity. So, but you know, specifically what Heisenberg is, you know, he's working with Sommerfeld, and so very relativistic in nature here. So then, once again, this is the atomic inflection point. So they get the Vergiate crash information. Heisenberg, who will eventually become the head of the Nazi atomic bomb program, is he starts publishing some interesting stuff immediately afterwards. And then within the same year, Otto Hahn and Fritz Strassmann would discover nuclear fission. And then in 1939 is when Heisenberg is made fully the head of the Nazi nuclear bomb program. Then Niels Bohr, he arrives in the U.S. with the news of nuclear fission, and however, he can only really he doesn't convince anybody, because he is, you know, still head of the Copenhagen interpretation, so he can't really explain what's going on in the physics of the, you know, he can't really explain Heisenberg's physics because he's no longer in Germany. He's actually in Denmark, and so his message goes unheeded in January. However, then what happens, which is that on July 16th, after months of inaction, Szilard and Wigner. Now, you'll remember Wigner is actually part of the Wigner-Weil transform, which I'm not sure I brought in both Wigner and Weil, but basically they're part of the group that was showing the exact way you can treat quantum physics from a fluid dynamical perspective if you use a phase space formulation. So Wigner shows up with Szilard, and they convince Einstein that there is a real bomb threat, and then that leads to the letter from Einstein with Szilard and Einstein writing the letter that gets the Manhattan Project off the ground. So now we're going to move forward to another epoch in history that's very important. That is the Hannes Alphen. I hope I'm pronouncing his name properly. He actually invents basically the field of magnetohydrodynamics, and that comes out in 1942. And he basically he just sidesteps the anti-ether of the basically the axis. I mean, excuse me, the Allied powers are kind of anti-ether, because anything the Nazis are pro, we want to be anti. So he sidesteps that and basically calls all of space plasma. So it's just Alphen's work is basically saying that you know that ether is plasma, and he doesn't actually ever have to utter the word ether. However, he treats it exactly as ether. I'm going to have to speed up a little bit looking at my time here. Excuse me. So Then we have in 1943 the seizure of Tesla's ether legacy, and why I brought up specifically the Alphen is because this is going to be the head of plasma. In other words, this is a huge movement in plasma physics. This is an enormous event, his publication. So it's going to be, anybody who has anything to do with plasma physics is going to be very interested in this. And plasma physics, of course, is very closely related to these various things that we're working on in highly advanced physics at the time. And once again, this is before the bomb. So then in 1943, Robert Oppenheimer's brilliant student, David Bohm, he completes his doctoral research. His topic is not abstract nuclear theory, but the intensely practical problem of controlling plasmas in magnetic fields. Work is the key to the Manhattan Project because basically industrial scale separation of uranium fuel relies upon his development. So one of the people who is very, very crucial to us getting the bomb before the Nazis is David Bohm specifically. So whenever he completes his PhD thesis, it's immediately classified before it's submitted to anyone. And Oppenheimer has to just say, "Trust me, bro," and to the staff at Berkeley, and so Oppenheimer just gives him his PhD by telling them, "You're just going to have to take my word for it because it's secret." Then basically, let's see, go up to the Bohr defects. And in 1944, this is when finally, on June 5th, the Allies seized the captured crash materials. Then in 1945, on July 16th, the Trinity test, and that's when you actually have the bomb go off, and that's when Oppenheimer says, "I have become death, destroyer of worlds." Now I'm going to do a short retrospective here because I don't have. Wow, this is taking so long. And that is that basically Oppenheimer, he's known for quoting the Mahabharata in nearly every lecture, and the Nazi regime actually associated themselves, and this is where cultural appropriation was first a thing that people noticed might be a bad idea, and that is when the Nazis basically decided that the people of India, their history was not their history. It was the Nazis' history. And so they actually took up the whole Indus Valley civilization as their own. They said, "Yeah, that's our history, not your history." And so it's important to know that they associated themselves with a lost technological civilization that is in the Mahabharata, where they have the flying machines, the Vimanas, and where there is this Wunderwaffe, which is a wonder weapon known as the Brahmastra, where the effects are described similar to nuclear explosion and fallout. And basically Himmler kept a copy of the Bhagavad Gita, which is a subsection of the Mahabharata, in his vest pocket till his death. So, and it's also important to know that from 1933 to 1935, the number of archaeologists jumped from 1 to the chairs. The archaeology chairs actually jumped from 1 to 9. And basically, so part of what was going on is they were in search for ancient lost technology after 1933. So now we're going to enter the nuclear secrecy era. And this is where Dulles basically masterminds Operation Paperclip, brings 1,600 Nazis, into the U.S. and basically also he then puts a lot of them into the intelligence apparatus, which was the OSS at the time, I believe. And then by 1947, he's converted a huge number of Nazi intelligence assets all throughout Europe to be ours, and also a lot of the people who were the Nazi scientists, etc., all became part of the eventual CIA, which he then heads for the longest period of time. So he actually, this is an example of one of the people. Reinhard Gehlen is the one of the cases where they basically just said, okay, you can be. You were fighting the Soviets and trying to learn all about them, and you're this basically intelligence operation. Well, now you're our intelligence operation against the Soviets. So there was basically an instantaneous position of Cold War against the Soviets through basically Operation Paperclip. So and also there was the Operation Gladio was this huge stink where the CIA kept kept troops all throughout, hidden all throughout Europe, and it really pissed off most of Europe about. But that was also them using the Nazi, taking over the whole Nazi infrastructure of spying, etc., and basically saying you're now ours. So 1947 is the Roswell incident. This is very shortly after, paperclip, etc. And then we have just from July 8th to July 26th, you go from having the Roswell incident to the formation of the CIA. And then it becomes in 1947, basically the secrecy becomes official, and it's a response to the wave of sightings. The U.S. Air Force establishes Project Sign. It's the first formal but highly classified studies of the phenomena. So what you should be kind of seeing here is that there is this very strong overlap between nuclear physics and UAP physics. So what's important here now is like I said, the apex of this talk is David Bohm. So in 1949, David Bohm is then called before the House on Un-American Activities, and basically he refuses to testify against Oppenheimer, his PhD advisor, and so this ends up. This is right in the center of McCarthyism, where the Red Scare and all of that's happening, and they're basically there's a commie under every roof, and so basically the new CIA, which is populated with a tremendous number of former German intelligence. Well, they were fighting the Soviets before, so this is no stretch for them to suddenly decide to fight Soviets in the U.S., and that's where basically a lot of the McCarthyism, etc., kind of starts to make sense. So basically David Bohm's called up for this House on Un-American Activities, and they're basically just kind of deciding we got to protect the bomb at all costs, and anybody who was even slightly socialist associated is under an enormous amount of fire. So he's then in 1950 he's arrested and indicted in contempt of Congress, but he's then acquitted. And he ends up kind of blacklisted from all the universities and ends up having to go to Brazil. So now here's where there is a major point. It looks like I duplicated things. So now what you have is this: there is nuclear secrecy is a huge deal. However, the Russians end up actually demonstrating they have the bomb, I think, around 1949. I probably should have added that here. And so there is this interaction here where the secrecy is no longer really even valid, and numerous scientists are kind of showing that they don't want all of the power of the nuclear bomb in one set of hands alone. And so because they want they don't want this asymmetry of power to kick off yet another world war, basically. So in 1950, he's arrested. Then in 1951, Bohm's textbook, Quantum Theory, it becomes the dominant university textbook on Copenhagen interpretation for at least a decade. However, because he's blacklisted, the Princeton lets Bohm's already suspended assistant professorship expire on June 30th, 1951. And then 5 days later, his paper that eviscerates Copenhagen, which he had just written a book, just came out June 30th, or excuse me, it was sometime I believe in June, just a month prior, his book comes out, and then 5 days later, they receive papers that are this attack on Copenhagen interpretation. And at that point, Oppenheimer advises Bohm to flee the country. After he does this, basically he's broken ranks on the secrecy, and he has to flee the country to a non-extradition state, and which is Brazil at the time. And and then as soon as he arrives, gets his passport taken, etc. And then Oppenheimer calls an emergency meeting of the IS, tells numerous attendees, including Einstein, if we cannot disprove Bohm, then we must agree to ignore him. So what you need to understand here is that Bohmian theory is an extension of ether theory. That is a very crucial point that I'm trying to make here. That it's not exactly clear because I'm trying to just relate all of the facts of how this series of events went. And it looks like I have very little time left. I'm going to try to get to the end here as quickly as possible. So so you basically, let me try to reassess how I can try to make this a little bit faster.
Well, and Shiva, if you're going to run over a little bit, maybe we could ask, let me bring Mike in real quick. Hey, Mike, is it cool if Shiva runs over a little bit?
No problem.
Okay. We'll do that then. Okay. Yeah, sorry. I just don't want to put you under the gun, sir.
Yeah. There's so much information here, and I'm getting people to kind of drink from a fire hose, because I'm hoping they can go back over these notes, in a secondary time, so they can look at the notes and be like, well, hold on. And especially when it comes to the epoch of 1951 and 1952, because this is really the apex here of where there is kind of this obvious change, where we can kind of see hints that perhaps what is occurring. And this is the narrative I'm sort of supporting as a possibility of, where is the secrecy? How is it manipulated? Who's doing the manipulation? And of course, we know that through the Church Committee and a variety of other things, that the CIA does do disinformation specifically against the American people, which is part of what is coming out in all these hearings on UAPs. And so, and I'm going to start hitting those points a little more clearly here, since I've got some more time, but I'm still going to have to try to go pretty fast, so I don't want to take forever either. So let's kind of recap what's happening in 1951 to 1952 era, because this is really an important set of important set of dates. And I condensed this down. This story is so much more broad and vast, and I'm only trying to give you the high points. And as you can see, there's a lot of high points. So what you have is David Bohm publishes the book on Copenhagen, immediately goes and mails in his proof that Copenhagen is bullshit. And then Oppenheimer says, buddy, friend, get the hell out of this country now. And then helps him get his try to get a professorship in Brazil and personally, and then immediately goes into attack mode, because of course Oppenheimer is under the gun. The House on Un-American Activities is basically down his throat and accusing him of perhaps breaking nuclear secrecy with the Soviets. And so he's privately completely supporting Bohm, and then publicly he's saying we gotta ignore him, we gotta if we can't disprove him, and he continues to be his academic opponent there forward, even though he is privately a friend. So that should be kind of obvious that basically Oppenheimer is part of the IAS, which is very closely tied to the Atomic Energy Commission and the entire state of secrecy. He is very obviously preserving secrecy, as he has been told to do and threatened to do, and will eventually be brought up on charges for not sufficiently doing, apparently, because in 1954 they end up arresting Oppenheimer over the same stuff. So but again, this is 1951 that this occurs, and just a bunch of events kind of start happening all right in a row. And so you have the Invention of Secrecy Act in 1951 also, and that basically blocks patents and anything that might be harmful to national security. Then you have the Washington National UFO Flap that it also happens in 1952. So right from 1951 to 1952, you have a huge series of events that are important in our storyline here. So so that is just kind of a big hint of what happens with the Bohm affair, that he is this trained as a plasma physicist, and he's central to the Manhattan Project. Then he writes an entire book, rejects that writing, which is awfully weird, isn't it? And then has to flee the country. And so let's go forward from here now. So now there's this scientific rebellion against secrecy. So it's important to note that Dirac, this is when he actually publishes a little known paper called Is There an Ether? And so this is where you can see solidarity. And throughout this paper, he goes through and says, he basically lays out how it is that there's a substantive space, and that everything in quantum physics tells us that we have to treat space as a substance. And he concludes the paper with, we are rather forced to have an ether. And of course, that paper is ignored. And most people don't even know it exists. Let's see. All right. So then we're moving into the anti-gravity revolution. This is when things start picking up in an interesting way. So in 1952, also, year of the UFO flap, that's when Burkhard Heim basically is continuing the German ether program. And basically he adds his own, spin to it that I'm sure a lot of people here already know a whole lot about. And then we continue forward, and you've got the we've got T. Townsend Brown basically in his demonstrations to the Navy. And so we have this rise of manipulation of space for the purpose of gravity manipulation, not anti-gravity, because because a good pedant will say, well, you specifically have to. I'm sorry. It's just that sometimes when people get too hung up on terminology, I find it funny. So in 1956, we actually find that there is this extreme interest of the entire, aviation and all of these major corporations that during paperclip, basically many of the paperclip scientists were also put into specifically, which were the ones? Let me look at it real quick. So some of the major ones were Lockheed Martin, which was actually Martin, and Boeing was actually a previous name, but these are all known as Lockheed Martin. Boeing and General Dynamics, they all basically get a lot of the scientists from the paperclip program. So it's of course interesting that they would then have this information about what is nuclear secrecy, what is UAP secrecy, what is space-time engineering, and basically the secret of the ether that we now have to make sure that nobody actually ever does anything with. So they basically exposed their extreme interest. Then in 1957, we basically sort of have this resurgence. So in the background, you have Bohm is in another country continuing to hammer away at the arguments that were presented by previous generations. Like you have von Neumann had this proof that you couldn't have local hidden variables, and therefore you couldn't have hidden variables at all. And that was actually kind of, Bohm was answering that and saying, actually, if you allow non-locality, you can have hidden variables. And that is specifically what gets Bell to write his famous paper on Bell inequalities eventually. So, understanding that is an important part of this story as well. And we'll get back to that. But so you have this physicalist revolution starting to back up after this rebellion against secrecy. So various, like even Niels Bohr wrote a famous open letter to the UN saying we've got to end a nuclear secrecy after he'd already attempted with Churchill and the US president at the time, and with no effect. So in other words, even Bohr, who is basically the figurehead of the Copenhagen interpretation, and in my opinion, his work was then leveraged to keep people confused. Even he is saying we've got to end nuclear secrecy. You've got Bohm rebelling, you've got Dirac rebelling, you've got Einstein also working with David Bohm on resurrecting the EPR paradox. So this is where EPR gets resurrected, because it kind of died off for like over a decade. And that's the Einstein, Podolsky, and Rosen. That's basically the argument against Copenhagen by Einstein, Schrodinger, and all of these other people. So then you have the corporate takeover of gravity research. So this is Oh no, man, I don't want to skip this. The AB effect, the Aharonov-Bohm effect, is basically when they submit their paper, they basically prove that our understanding of space doesn't work, and they basically just show that the ether has a momentum in the fluid itself. And so it's just kind of there are these various things that are happening where Bohm is starting to win the fight, and the anti-gravity revolution is starting to be this group of people who are manipulating the physical space, and which is, of course, don't say ether. So here's an interesting thing that then happens. Lewis Witten is a top gravitation physicist working at Martin Marietta, and he is participates in the Gravity Research Foundation. But then he also is responsible for creating the corporate version that is kind of in competition with that privately funded Gravity Research Foundation. So he actually does for Lockheed Martin, which eventually becomes Lockheed Martin. He basically starts to collect anti-gravity theorists, etc., for the corporate agenda. And so this is for the military industrial complex. And then in 1964, Bell's theorem. So this is basically kind of like Bell. He takes Bohm's work and extends it. So in other words, Bell's work is an extension of Bohm's work, and he extends that work to basically point out, it's like, okay, well, you can actually have a theory that works within these very specific parameters. It won't work in these parameters, it will work in these. So he is a huge proponent of David Bohm's pilot wave theory. And what's funny is, now today people act as though pilot wave is not something you could take seriously. However, it was something everyone was taking quite seriously at the time, and it was actually rising to prominence before it was killed by disinformation operations. So then we have Bryce DeWitt in anti-gravity. A lot of people are going to be familiar with him. He's part of the Wheeler-DeWitt equation, and basically we're starting to get these tools that are how we can manipulate the fabric of space. However, then this is something I need to do a little more research on, but basically I'm not sure who was responsible here between Wheeler and DeWitt, but I believe Wheeler may have been a central figure in sort of working against anti-gravity, and because he was part of he was associated with CIA and DoD, and he kind of rebrands DeWitt's work, and DeWitt is not happy with Wheeler's rebranding. Then in '69, you got these CH-SH inequalities, which is basically an extension and formalization of Bell inequalities. So it's just making it concrete that there is this way in which you can do these tests in quantum physics, and what's possible and what's impossible in our understanding of it. And it's not what's reported to you now, that because there is this conflation of non-locality with spooky action at a distance. Those are two very, very, very different things, because there is non-locality in Bohm's work, which is pilot wave theory. However, what people misunderstand here is that the idea of non-locality itself is something that becomes a point of confusion. The term non-locality is well known in fluid dynamics, and in fluid dynamics, which is, of course, plasma physics is an offshoot of fluid dynamics, and everybody's been, who are the central characters in the story are all fluid dynamics based. So when they were talking about non-locality, what they're talking about is what we understand in fluid dynamics to be non-locality, which is, to put it very simply, in fluids, there is non-locality. That doesn't mean that there's some spooky weird connection between them. It just means that it acts like a field of interconnected gears. Fluids kind of act like that. So whenever you consider, if I want to turn this gear, I have to think about the properties of all of the attached gears, their weight and, their inertia, their, if how they spin, etc. So in other words, there is a non-local influence on this little point that I'm examining that I think of as a separate thing. I think of this one gear as a separate thing, but all the internet connected gears have to also be considered. That is non-locality in in fluid dynamics, and therefore in Bohm's idea and all of the people who are trying to promote a fluid version of quantum mechanics. That's their understanding of non-locality. That is not what we are now sort of told, and so that is a perfect point in which you can confuse people with. Oh, okay. So this is, we're continuing forward, and basically now pilot way is starting to win. Space-time engineering is starting to win. And there's something called the Rochester Conference. And there's a character called E.T. Jaynes. He is this huge central world authority in information theory and statistical interpretation, but basically in statistics. So he actually then just tears Copenhagen interpretation apart in 1972, and for him to be basically telling everyone, hey, these people who are using statistics don't understand statistics, when he's this world authority in statistics, was just an enormous blow for Copenhagen. So that was kind of a huge possible turning point that will eventually get shut down. Because nobody talks about E.T. Jaynes anymore, and he's kind of ignored, forgotten. So then we, of course, in 1975, we have the Church Commission, which exposes the deep state and all of their stuff that's going on. So now, this is where the second wave disinformation campaign actually starts to occur, and we have a friend, Jack Sarfati, who may have not known he was at the center of some very interesting things that were going on, because he points out that he was recruited by the CIA in the 70s. Well, it turns out that in 1975, the fundamental physics group is formed by Elizabeth Rauscher, and she's a staff scientist at Lawrence Livermore. She's very connected to CIA, DIA. And so there's some of the things here, some of the characteristics about her. So she starts the group. She's this interesting character that then this group is what's responsible for our understanding of Bell inequalities being exactly the opposite of what Bell intended. In other words, this is where we get the idea that Bell inequalities prove that reality is fundamentally just randomness underneath the surface, and you can't know it. All of that is actually basically brought up much later than Bohm and Bell and all those who are trying to prove something very particular. And so this is kind of a hijacking that occurs right at that point. And they fully take credit for having basically pivoted science at that point, once again, towards kind of a Copenhagen interpretation. And this is where it's entirely where the reinterpretation of Bell comes from. And we actually can track down some of the interesting ways in which the fundamental physics group is they're the house theorists for the CIA, DIA's espionage program. In the 1990s, she was living with somebody who was a CIA MK Ultra operative. So she's very, she has all of these different things that just kind of show that it seems very likely that her intention with the creation and impetus for the fundamental physics group was specifically to promote Copenhagen interpretation. Then in the 1970s, basically everybody kind of forgets E.T. Jaynes. And by the 1980s, we have decoherence theory, which is just Copenhagen interpretation with more hand waving. And then by 1984, we have Ed Witten, the son of the Martin Marietta gravity physicist Lewis Witten, launches the superstring revolution. So in other words, this is where we can see these various people who are connected to the intelligence apparatus, who are all part of what a lot of commentators today are now saying is the center of what caused physics to go off the rails. And so what I'm trying to put together here is the possibility, and once again, it's a possibility of that nuclear secrecy was the reason that we started out, keeping certain aspects of physics, especially things like plasma physics, which a lot of you will know that Alfvén also faced a lot of blowback as well, and he's kind of associated with, oh yeah, magnetohydrodynamics is purely perfectly good. However, a lot of the other stuff he said, let's just put that aside. So now the final capstone on all this is on August 1st. One of the scientists who got the 2022 Nobel Prize for basically some of the Bell tests, which once again, still in 2022 during the Nobel Prize, they are conflating non-locality with spooky action at a distance, and basically Anton Zellinger, just on August 1st of this year, published a paper with experiments that showed that, once again, Copenhagen interpretation is not viable. So that's mostly what I wanted to put together here, is just that the revolution against nuclear secrecy and against UAP secrecy has been kind of raging under the radar, in my opinion, for all this time, and with lots of people with their own kinds of take on it and their own understanding of it, and I hope that you will look into those various things that you've seen come up on your screen. Go back, look at this video again and look at some of the things that I brought up there, because there's a lot more to this than I have actually brought out here. I just tried to pare it down as best I could, and so this is the best I could do when I kind of just ran out of time to deliver this to you. So that's going to be it for me.
Shiva, that's amazing. That is amazing, man. You've gone through so much stuff. So let me take the slide share down. I'm going to take that down, and I'm going to bring everybody in. Okay, I think this is everybody that we have with us. Yeah. So guys, let's put our hands together and give Mr. Shiva Meucci enormous applause. And so, Shiva, this is like in semi-private conversations, I'm going to out you here. You have decades of writing on Quora and other platforms, and I've been urging you to gather all of those together and put them into one place. And, I have the same problem. I've been writing for like 20-something years, and so I have stuff on all these different platforms, and it's like, it's a pain in the butt, but it's worth doing.
Yeah, I'm going to put all that together. It's just sometimes, I get involved in research and and trying to figure out exactly where to go, because basically where we are now, where all of us are, is we are in a junkyard of science. In other words, think of it as an automotive junkyard, and throughout it there are broken parts, there are working parts of a lot of different cars, and it is an important job to go and find working parts, and some people do that, and it's an important part to figure out which parts go with which cars, and then there's a job of somebody putting those pieces together into a workable engine and a workable car that is from one single car, and and then there's the job of cleaning all of that up. And so I think a lot of the people in the community here are doing these different jobs, and so I hope that I can continue to contribute to this community.
No, I love it that you were going through the history and revisiting a lot of these decisions that were made, right? And like obviously I haven't been part of any of those decisions, but I have been part of groups making decisions that have ended up in the news later. And one of the things that I've seen is the news, the media, history, prevailing scientific wisdom, they tend to have this reductionist view on things, where they're like, okay, this is what we decided and here's why. And in reality, there was a massive debate and none of the solutions fit perfectly at the time, right? And so that's what you're pointing out. You're saying, okay, the history as it's written is not as clear cut as people think, and it could easily lead us to different conclusions that provide us with better scientific tools.
Yeah, the people pretend that science was, we reached these consensus points, and the truth of the matter is, no, we reached dominance points. In other words, certain people dominated, and the others continued to say, no, the consensus is wrong, who were fully, directly, dead center of the developments of these theories. In other words, people like Schrodinger, people like Einstein, all of these people did not agree with where it went, but we're told it's a consensus. It's not a consensus, it's a dominance.
Yeah, yeah. No, that makes complete sense. And again, you are asking the hard questions. And again, this kind of goes back to your work, but this also goes to, I guess, anybody in the audience who's listening. One of the things that I've been doing lately is using ChatGPT and some of the other AI tools that are out there. And you can use those to research things like this more deeply, as well as, like, as you mentioned, we're in this junkyard of science. They can go through the junkyard for you, find bits and pieces, and bring those together, and that's just getting better and better and better over time. So,
and it is important as you're doing that to check back against it and tell an AI to recheck things, because they still do hallucinate, and they'll hallucinate entire facts, unfortunately. And so they themselves are a junkyard. And so
yes,
they're a powerful tool, and occasionally they'll hand you something alongside these beautiful jewels of knowledge, something that is complete crap. So it's like,
and actually, a case in point, this happened 2 days ago to me. I was having it synthesize a story from transcripts, and I said, okay, generate some quotes for me, right? And so it took generate a little too literally. I had these amazing quotes, and I'm like, I don't remember the person saying that when I interviewed them. And so then I had to go back through, and I'm like, okay, find me some quotes and attribute these, because I need to prove that this was said.
Please don't hallucinate a bunch of stuff, please. But yeah, they still have that problem. But it doesn't mean that an imperfect tool is not still useful. You just have to be aware that it is an imperfect tool.
Yeah, yeah, and it's getting better and better. And I think especially for tasks like this, right? I mean, again, you're going through over a century of scientific thinking and saying, okay, what were the decisions that were made that influenced the rest of it, And it's so much, and you've barely scratched the surface. I mean, you were just looking at one kind of mainstream part of it, right? But then if you went into a different branch like material science, I'm sure that they have just as many of those decisions there,
What's interesting is material science is kind of they kind of are a rebellion against theoretical physics. When you go into material science, you find that they're kind of giving the finger to the mainstream ideology and just kind of going their own way, which is very interesting.
Yeah, it's amazing. Well, let me see. So we're at 3:22. So we're pushing it a little bit. So why don't we do this, Shiva? Let's put our hands together one more time and give you an enormous applause. I'm glad that you've returned. I want to have you back more in the future. Again, you're just helping us examine physics more closely. And then what I need to do now is go to Mr. Mike Gamble, who has been patiently waiting.
Can I have one short question here? Is it possible?
Oh, yeah.
Yeah. So first of all, Shiva, great presentations. Thank you so much. So first, if you haven't already, please share the document with us, because I would really like to read through all of it again. And second of all, do you speak German? Because we are digitalizing a lot of German historical documents right now, and maybe some of them could fill in some more details around the 45 to 55 timeline.
Yeah, that's actually one of the best uses of AI is translation. And so I very frequently use AI for translation.
Let's connect afterwards. So I think we would, I would like that.
Joel, why don't you put your contact info in private chat, and you guys can chat. Okay, so let me do this. I'm going to take everybody out now, and I'm going to go to I'm going to go to Mr. Mike Gamble. Mike, welcome back. You too, sir, have not been here in quite a while. You've been working on a ton of projects in the background. You have been working on the Graviflyer. I know there's one. You have some inertial propulsion stuff that you've been working on. And then today, you're actually going to be giving us a really introductory lecture on Nikola Tesla and the idea of resonance, right?
Correct.
Awesome. Okay, well, let me do this. I'm going to put your slideshow up, and thank you again so much for coming back.
Let's see. We got to start it here first.
Oh, I'm sorry about that. Yeah, we were testing earlier. I'll scroll right up to the beginning. Oops.
We're almost there.
Okay, there you go.
There we go.
Okay, Mike, take it away, sir.
Well, okay, I'll skip the first page, introduction. I think you all know me. I just thank you for bringing me back, and we'll continue on. So what we're going to do now, instead of working on my resonant motor, which I've been working on for a few years, we're going to stop. And I've had a lot of questions from a lot of people about the Tesla's electrical resonance. So I decided to do an in-depth research on the resonant part as it applies to the motor. The problem is there's not very much about electrical resonance written in modern day textbooks. The presentation's in three parts, starting with Tesla's history of it, and then the theory of it, and then physical demonstrations. And so that's what we're going to look at today. Looking back at the history, to really understand what Tesla understood, you have to look at his patents and dig through them, because his resonant work is sort of secondary or side issue when he wrote up the patents for his machines. And so we'll start with this one, Tesla's patent 511,916. It's for a vibrating steam generator, or an oscillating one. I circled the generator portion, which is on top there. The bottom is just a vibrating steam motor. It moves the magnetic armature up and down inside the field coils to generate the electricity. That's not the part we're interested in. Digging into the details on the patent figure there, shows the generator portion along with the resonant description. However, if you take it on this side, the print's way too small to read, but it does show that it is written by Tesla. So we'll zoom in on that and then discuss it. So we're looking at the generator portion here. You got the coil C prime, which is your generator coil, and then on top of that is wound another coil D prime, and in shunt with that is H prime. And what Tesla wrote on that, I just put in the quote there. It says, this is from his own words. I also put in the modern day translation, but that's irrelevant. In the circuit of the D coils there, showing the condenser H prime, it needs only be said that the proper value of the condenser, the self-induction of this circuit, can be neutralized. Such a circuit will have certain natural period of vibration. That is to say, when electricity therein is distributed in any electrical or electromagnetic vibration takes place, it depends on the capacity and the self-induction. Such a period may be varied according to match the period of the engine. Now, the nomenclature is a little bit different, but what he really designed in those horse and buggy days there was a solid state, no moving part, parallel resonant voltage generator. We know it today as a tank circuit. Where we go? Oh, we got to be up there. Okay. Another patent here on resonance, 512, 340 there on pancake inductors. The picture there is sort of self-explanatory on the first one. You just take a length of wire and wrap it in a spiral. And figure one shows the regular air core, and its induction is a function of the electromagnetic field between the adjacent windings. Figure number two there, what Tesla did is he wound it with what we call bifilar winding, which is two conductor, half length, and then he spliced it together in the center. What this does is it increases the electromagnetic field between the windings, and by default, the inductance also increases. And then we'll move on another one, patent number 645,576. We know this today as a Tesla coil. His original design was for generating and transmitting resonant high voltage, high frequency electrical power through a tuned transmitter receiver system. Nowadays, we just use it for making big sparks and simulated lightning. One thing to notice over on the schematic section, when he built his, he used his pancake coils. Now, the modern day ones all use cylindrical coils, so there may be some differences in its operation. Back in 1892, Tesla made the statement that electrical power is everywhere present in unlimited quantities and can drive the world's machinery without the need for coal, oil, or gas. If you hadn't heard the story, it's rumored in books and on the web that Tesla built and drove an electric-powered Pyrrhus Arrow back in the early 30s. That's where I started taking those stories and analyzing them to see if there's any truth in them. And when I did the reverse engineering, it proved Tesla's design was valid. And that brings us to the next slide. This is the patent 685,957 for a resonant energy device, sometimes referred to as radiant energy. The background is his patent there with his signature on it. In the middle there is the reverse engineering that I came up with, and it's absolutely identical except for the nomenclature. The biggest difference is on the right-hand one there, he used what he called an interrupter, which was a make-break switch spun by a high-speed motor. Nowadays, we use a PWM and MOSFETs to do the same thing with no mechanical interaction at all. It's all solid state. That was the history lesson there, quick one on Tesla resonance. Now we'll talk more detail in the basics of electrical resonators themselves. And I don't take any credit for the resonant work. Tesla did it himself 100 years ago. My only contribution is many years of researching and documenting of it. So starting with the tank circuit, however, a parallel resonator there is normally not drawn as the top picture. It's normally drawn as the bottom picture, but it does the same thing. Digging into the details of a parallel resonator, the input current, as you see with the red line there, flows only through the inductor, and the capacitor, the resonant current bounces back and forth between the capacitor and the inductor. The equations that cover that for the resonant current is the resonant voltage divided by the capacitor impedance. And the bottom one, equation 2, is the input current minus the resonant current is equal to the voltage divided by the inductor impedance. Down at the bottom is the S-plane frequency term, which is a minus 2 pi resonant frequency over in the imaginary plane. Now, those two equations can be combined and reconfigured to give you the resonant current, resonant voltage of any resonant circuit LC combination given its input current. Moving on to the series resonator, the input current is also the resonant current, and it flows through both the capacitor and the inductor in series, which is where the name comes from. This one, the resonant current is equal to the capacitor voltage divided by the capacitor impedance and the voltage across the inductor divided by the inductor impedance. That's both 1 and 2 are basically Ohm's law. And then the S-plane frequency term again. Similarly, those two equations can be combined and reconfigured for series resonance to give you the resonant current, the inductor voltage, capacitor voltage, given the input voltage of any series LC circuit. This chart sums up both the parallel and series specs or properties. On the parallel resonator, the current or the voltage is constant and the current increases due to resonance. There's 0 degrees phase shift on the input, and the current is minimum at resonance. And you go over to the series resonator, it's just the opposite. The current is constant and the voltage increases due to resonance. The input phase is still 0. However, the current is maximum for series parallel or for series resonance and minimum for parallel resonance. 100 years ago, Tesla made the statement that resonance is the key to tapping the ether power. Looking through his research, he also used the terms ropes and tubes of ether force. You'll find that if you dig into his work. Now, the way this applies to what we're doing here with electrical circuits, if you phase shift the current of an electromagnetic wave, either plus or minus 90 degrees, it changes it from a traveling wave to a standing wave. And thus, the resonant current just sloshes back and forth between the capacitor and the inductor, but what it generates is a resonant magnetic field. This is very similar to what a regular antenna does, only it generates a standing resonant electric field or wave. And as with any antenna, they can both transmit and receive. And this standing magnetic wave resonates directly with the ether field, drawing the additional power from it. In electrical terms, a resonant circuit can generate more power, either voltage or current, than what comes from the system's power supply. Now we get to the fun part, doing the real hardware. That's what I like doing. After we did the theory and the history, we start working with the hardware. So resonant calculation there for frequency is basically the inverse of the square root of the LC product, and it's the same for both parallel and series resonators. The second term there is the quality factor or Q factor of resonance, and the equation for that is the frequency times the inductance divided by the resistance. So now if you want to improve the quality factor, you have two choices. You can either increase the resonant frequency, which is in the numerator, or decrease the inductor resistance, which is in the denominator. And then we'll start working on real stuff here. We start with a 500 millihenry inductor which, at 80 ohms, and it's resonating against 11.93 microfarad capacitor with a Q factor 2.36. And if you look at the chart there, I guess I don't have the cursor control, but the blue line, which is the output, is a very wide frequency band. It goes from 20 hertz up to 100 hertz and very little amplitude. However, on the right-hand side there, if you put in 200 milliamps into that circuit, you'll get 104.8 volts out of it. Now, using the same inductor, upping the capacitance about 2 microfarad to 13.98, and lowering the resistance from 80 down to 15, it'll now resonate at 60.19 hertz with a quality factor of 12.57. And if you look at the lower picture there, you'll see it's very narrow band and very high amplitude. So that same 200 milliamps input will now give you 476.7 volts output. The next item on working with resonant circuits is you have to tweak them. So we'll take a detailed look at tuning of them. And this slide here starts off with, we have a 0.637 Henry inductor and 12.33 microfarad capacitor, resonates on parallel resonance at 56.8 hertz. Now, if you run that slower, say 47.2 hertz, the purple, which is the current, and the blue is the voltage, the current lags by 50.4 degrees. The voltage is 16.8, and you get 30.4 milliamps. Now the middle picture, as you increase the frequency to the resonant point, the current moves over and is now 0 degrees phase lag. They're both in phase. The voltage stays about the same at 17. The phase goes to 0, and the current drops from 30 down to 16. And then if you increase the frequency some more, the third picture, the bottom one, the phase now leads by 66 degrees. The voltage stays at about 17, and the current goes back up to 30. So that proves the point that the current is minimum at resonant for a parallel resonator. Now to do the testing of different parallel circuits here, this is a rough block diagram. You have the signal generator feeding the parallel resonant circuit. Channel 1 of the scope monitors the input voltage. Channel 2 monitors the input current through a current sense resistor. And then I use a clamp-on amp meter to measure the resonant current, because you can't put a current sense resistor there because it screws up the tuning. And then we'll do it for both high frequency and low frequency circuits. So we start with a low frequency circuit. Picture on the left is a 0.5 Henry inductor, and it's actually running at 0.637 Henries against a 12.5 microfarad cap, which is actually running at 12.33 microfarads. The current sense resistor is 100.4 ohms, and you can see it on the left picture there. Scope channel 1 is to the orange or the red clip from the signal generator. Channel 2 is to the black clip, and then the clamp on is on the yellow jumper between the capacitor and the inductor. And you look over on the right there, the right hand picture shows the circuit running on the scope there. And then we'll do a detailed dump on the scope there so you can see it a lot closer. First one is we take MATLAB and we plug in the theoretical equations that we talked about earlier for a parallel resonator to determine the input voltage and the resonant current given the input current. And then we plug in the values that were on the scope there. And when you compare the two, the scope dump, that's the actual picture off the scope. And the one on the left there, not in color, is the simulation. And you can see they're absolutely identical. The time base on the is stretched out more on the sim. But looking at it, the thing is resonating at 56.1 hertz with a Q factor of 5.34. And being it is a parallel resonator, the voltage is constant for the input, for the inductor, and for the capacitor at 9.1 volts. The difference there is you look over at the current, the input current, which is the blue, and the yellow is the voltage, and you can see they're in phase. So you have 0 degrees. And you go down and you look at the purple, which is the output current, capacitor current, which is running 90 degrees out of phase at 43.5 milliamps. So the input is increased from 8.77 milliamps to 43 milliamps. Now, one thing that the sim does show you is there's about 3 or 4 cycles for it to come up to speed, which of course the scope can't tell you that. So the next chart, we'll do the same test, only now we're going to do it at higher frequency. So we're using a 1 millihenry inductor, which is actually going to run at 0.56 millihenries. And the capacitor is 137.7 nanofarads, which is a 100 nanofarad in parallel with a 39 nanofarad capacitor. These are shown on the left-hand picture there. the two capacitors in parallel, and then the scope channel 1 is on the input lead of the generator, and scope channel 2 is on the output through the current sense resistor, and the clamp on is between the cap and the inductor. Looking over at the right-hand picture, you can see the circuit running on the bench and the scope view, and then we'll zoom in on it and talk about the details. Okay, the sim on this one says it's running at 18 kilohertz. Q factor is 16.5. If you look at the blue and the yellow, you can hardly see them because they're superimposed because it has such a high Q factor. They're almost perfectly synchronized. Looking at the sim, you see a very narrow bandwidth and a very high amplitude because of that high Q factor. So looking at the numbers, you have 5.3 input volts, which is the same for the inductor and for the capacitor. And you get over to the current, and the input current is 4.98 at 0 degrees phase. And the output is 91.48 milliamps at pretty much 90 degrees. But if you look real close at the purple, it's not 90 degrees. It's the scope dump there is showing 40.73 degrees. The problem is there's a 49.25 degree lag in that clamp-on amp meter at 18 kilohertz. The thing's only good for about 1 kilohertz, so we're pushing the instruments. Then we move over to pretty much doing the same thing, only with series resonance circuits. Generator feeds the VN monitored by scope channel 1. Scope channel 2 monitors the current sense resistor, and channel 4 monitors the inductor voltage. And if you subtract channel 1 or subtract channel 4 from channel 1, you get the capacitor voltage. So it's a very similar setup. And then again, we'll do a low frequency and a high frequency test. So on the left there, you see the cables from the generator. Channel 1 is monitoring it, going into the inductor. And then the jumper wire feeds the inductor into the capacitor, and then it feeds into the current sense resistor. Channel 2 picks it up for the current. Channel 4 measures the in-between voltage, and if you look over on the scope there on the right, you'll see the circuit running and the scope view. Going back to sim, you take the three theoretical equations for the input current, capacitor voltage, inductor voltage from a given input voltage, and plug in the numbers that are running on the scope, and you get this picture. Scope dump is on the right, simulation is on the left, and they're virtually identical. Here again, the difference is the time base, which shows about 3 or 4 startup cycles on the sim, which you can't see with the scope. Looking at the data, you're running at 56.8 hertz, and you got a Q factor of 5.34. So looking at the scope, the blue and the yellow lines are in phase, 0 degrees shift. Now the difference here is the current is constant, so it's 51.56 milliamps constant through the input, through the inductor, and through the capacitor. The input voltage is 2.25 volts at 0 degrees phase. The red line is the capacitor voltage, which leads by 90 degrees, and the green is the inductor voltage, which lags. And so the 2.25 volts input is now taken up to about 11 volts on the outputs, and it's just the opposite of the parallel one. Now we do the same thing high speed on the series resonator. This one is 1 millihenry inductor, and 0.346 millihenries is what it actually runs at. against 137.7 nanofarad, which is the 139 in parallel. So on the right-hand side, you see the scope of the view, and the connections are pretty much the same, only the part values have changed. And then we compare the simulation to the scope dump on the right, and you see the blue and the yellow are running in phase, which is your input current and voltage. The red is the capacitor, which leads, and the green is the inductor that lags. And we're running at 23.07 kilohertz with a Q factor of 1.42. Now, if you look at the simulation on the left, the curve is very broad and not very high, which says you have a very low gain. And looking at the numbers, it substantiates that. The current is very high, 67.7 milliamps carried through. The input voltage is 2.46, and the output voltage is about 4 volts, which is very low because you have a low Q factor. But the thing to notice is, because the Q factor is so low, the capacitor is only at 54.8 lead, and usually it should be up at around 90. What that tells you is that combination of LC does not resonate at 23 kilohertz very good. So you hit component limitations on that one. And now we're going to apply what we learned about Tesla's resonance to the cycle-by-cycle resonator that I demonstrated back in 2022. For review, this is a picture of it running on my bench. We have the controller down here, instrumentation, the resonant system running the fan motor, and the scope there. The reason all the previous pictures did not have the signal generator in there because it sits up on top of the workbench, and I did the work down there, and I just run a power cable down. Okay, a close-up view of this thing. You have 2 half signs here. The green on the left is the phase A, and the yellow on the right is phase B. The purple is the input current, and the, I guess you'd call it cyan or light blue, is the total current. Power supply feeds 12 volts to the controller, and you see the scope there is connected to the tank capacitors, and the fan is running at 110 volts or 115, and it's blowing the air. So it does work. Excuse me. Running out of spit. This is the block diagram or schematics of the cycle-by-cycle resonator. Instead of running on AC, it runs on half signs. There's a capacitor on both leads of the motor that is shunted by MOSFET switches, and then there's an input resistor to phase A and phase B. So to start this, we throw the switches, switch 1 open, switch 2 closed, which places the motor coil, which is an inductor, in parallel resonance with capacitor C1. Then we hit it with phase A pulse, which is highlighted in red there, through the R1 resistor, and the red path and arrows show the current flow, and then the resonant current through C1, the blue arrows show the opposite current flow through the motor. That's phase A run cycle. Then the next thing we do is at the end of the first pulse, when it gets back down to 0, we throw the switches the other way. Switch 1 is now closed. Switch 2 is now open, placing the motor in parallel or in series resonance with capacitor C2. So the back EMF field, as it collapses, now feeds the current with the red arrows there into capacitor C2, partially charging it. And then we continue on with the start of the phase B pulse on the right-hand side, going the other way, which now charges the motor up the opposite direction through the red arrows. and then the resonant through the blue arrows, remembering that the capacitor was partially charged at the end of the phase A pulse. And then the cycle does the same thing. We now change the switches. Switch 1 open, switch 2 closed, which places the motor coil in series resonance with capacitor C1, and the residual from the inductance now charges or partially charges C1, and we're ready for the next phase A cycle. So there's 4 steps in this cycle by cycle resonator. The motor doesn't know the difference. It still thinks it's running on a 110 plug, but what's happening is the input power is decreased because you're partially charging or recycling or saving, whatever you want to call it. What the normal power of the motor would be just lost. And so then we'll start with the conclusions here. First one is the real resonant demo showed that the fixed inductors are not fixed at all. Their value varies as the current that flows through them. And 2 there, all analog circuits, you usually have to tweak them. For resonant circuits, it's even more critical. The higher the Q factor, the more you have to be careful to get the exact tuning. 3, parallel resonator increases the current, but the input voltage remains the same, and shows there on the chart the input voltage for all 3 components is the same. However, the current increases. And then we go to 4, and it's just the opposite. For a series resonator, the voltage increases, but the current remains the same. And so you got the 51.6 milliamps input, capacitor, and inductor, and then the voltage increases. And 5, this increased in resonant power, either volts or amps, depending on whether you're playing with parallel or series circuits. It is real and it's measurable. Number 6 there, the previous bullets are only mentioned in a very few old textbooks. You find very little in any new textbook on resonance. However, even though it is documented in old textbooks, there is nothing mentioned or said about the source of this additional power. And 7 there, Tesla stated in his work that this increased power was sourced by the standing wave resonance with the ether. And he used a lot of those terms, ropes and tubes, if you dig into his ether research. I don't understand what he was applying to. I think he was trying to visualize it or something or other. But number 9 there, sad to say, Tesla's ether resonance work was also swept under the rug along with everything else of his. When they sort of banished him, they swept everything he was doing under the rug. 10 there, in other writings, this ether field is also referred to as the cosmic carrier field. And 11, as there's no such thing as perpetual motion, but synchronous infinity with the ether field is a very close second, as it already powers everything from atoms to galaxies. And if I haven't bored you with enough of the numbers that engineers love, I thank you for watching this presentation on Tesla electrical resonance. If you got any questions, I'll try and answer them.
Mike, that is amazing. And you got your contact info in there and the Flux Space website. And I am not going to take credit for building that, but I need to do some work on that. So
it's viable.
Yeah, it works. I need to put in better BIOS for you guys. So, but yeah, the work that you guys are doing is amazing. And the work that you are doing is amazing. So thank you. Thank you so much.
I'm still working on the resonance stuff. When I'm not pitching here, I have 2-3 designs sitting on the bench. They picked up another guy well, Gerard, I don't know. Yeah, he's still there. But Thomas is another guy we just picked up. He's going up to Canada working on some resonant stuff up that way coming up. But yeah, we're very intense into resonance of both mechanical, electrical, and gravity.
So let me, Mike, let me do this. I want to, before anything else, as true to our tradition, and you have earned this through one heck of a technical walkthrough, let's put our hands together and give Mr. Mike Gamble enormous applause. Enormous applause. And, you know, I also want to give a shout out to Tesla Tech, Steve Ellswick, and that community, because this presentation originated there. This was something you presented there, and then you brought it here, and I appreciate that, because this kind of engineering goes into a lot of our systems too. So
yeah, well, I try to do whatever I pull together. I try to present it both at Tesla Tech and here, because the community is very similar as far as people.
Yeah.
What everybody else is working on is very similar in both groups, so I don't want to waste it.
No, that makes sense. And, you know, there is a fair amount of overlap in terms of interest. And this is kind of an aside. One of the things that I've found, I've been using the word tribe lately, right? Which I got from mainstream business culture. So that's bad. But, you know, the folks in our tribe have this collection of shared interests, and not all of them make sense, right? Like, alt propulsion, I was surprised to find out that pretty much everybody in our community is into UFOs in one way or another. That's not necessarily given, but it makes sense. The other one is consciousness. Consciousness is giant in our community, and it's not a direct relationship to alt propulsion or free energy. So, you know, it's just, I don't know, shared vision, I guess.
It sort of is. If you take it back to the ether, both the mechanical side and the call it spiritual side are overlapped at that level.
Yeah. So yeah, thank you again. I'm so happy that you were able to. Oh, you know what? Now I'm going to bring Shiva in. Shiva's hiding over there.
Hey, thanks for that presentation.
I'm in a consciousness chat group with Shiva and other people. So
yeah, and I agree with Mike that the consciousness it's directly related.
Well, do you guys want to do lab updates now? We do have Curtis with us. We sort of have Curtis with us. There we go. Yeah, so why don't we do that? It's 4 on the dot. Why don't we do lab updates, and then we can do open discussion if you guys are open for it. Hey, Curtis, did you have anything you wanted to share? Do you have any updates?
Just briefly, I'm here at the lab at Fullerton, wrapping things up, documenting stuff. So not really a long update. Again, I'll show you guys around real quick. This is a vacuum chamber, the pump, and there's the amplifier, and behind me here is the the electronics and stuff and the computer. So yeah, it's going to be quite a move. I'm trying to document how things are wired up, because I don't want to forget or not know how to put things back together once I get to the new spot. And again, I'll show you guys. This is the linear. Actually, there, it's relatively heavy. This is the linear experiment here, where we have the magnetic rail that I shared, where we're going to be putting the device in there and seeing if it can move it. So no longer will be on the torsion balance, which can get unbalanced, and it's an unstable equilibrium. So that's about it. Just,
awesome. Well, so while you're doing that, and I know you are doing, I mean, since Jim's passing, I know you were playing catch up, right? So thank you so much, because there's so much there. I wanted to show you, I just put this up on the Alt Propulsion website. This is actually what they call a facade or a facade, I think. Sorry, facade. For the actual video itself. And it's basically a collection of videos. Some of my films, some of them are presentations. I tried to put up some photos as well. And so this is really just kind of an overview of where things were at, when Jim left us.
Yeah.
And there's you. And so the bottom part of this is where things are going now that you're taking it over.
Yep. All right. Thanks, Tim. Yeah, in terms of where things left off, as you know, I'm still working on the theory paper. I started writing it this past week. I've gone over the derivations over and over. I'm putting everything in Mathematica, making sure that it's actual real stuff. And so fortunately there's a really good resolution to all of this, which is Jim's efforts is contributed greatly to figuring out inertia to the extent that I did. So I'm really curious about the claims that have been made by some of the speakers about getting propulsion. Hopefully we can see those things. I don't know what the theory is. But all that being said, I know there's other stuff out there, but with Jim really, a lot of as Jim was aware of a lot of this stuff, being a historian of physics and a physicist. He really knew where a lot of these things came from and who tested them, and when they were debunked or set aside and why. So
yeah.
So that's something that unfortunately we lost, but you can kind of see in his work, the things that weren't let go, or things like the Mach effect, right? The inertia being something we got to figure out or understand. And so that work is continuing for sure.
Yeah, absolutely. Absolutely. Well, let me see. You know what? Let me bring Drew in as well and see. Drew, do you have an update for us, sir?
Yeah, I was kind of hoping to put some graphics to it, but I ran afoul of my honeydew list for today. The short and long of it is, I've been running extended operations on thruster, the latest design, and let's see. I'm trying to put some thought to this. Basically, it's just another iteration of the current thruster I've been working on, and I've been trying to optimize it for a little bit lighter weight and a little bit higher output, and hopefully be able to stack up a little more thrust in it. And over the course of this week, I've tested it 6 times. So basically, it's about 2 hours, 3 hours on each test. And I have managed to pack up, as of a couple of hours ago, when I shut the thing down and tore it apart, I had managed to pack up 11,500 micronewtons, which is 11.5 millinewtons. And I know I can build this version of thruster for about $1 gram. This particular one that I tested was heavier, but that's just because it was a demo unit. So the short and long of it is I have Earth unity. I have achieved Earth unity of 1.17. So that's 10% above its own mass that it can actually produce thrust of. So theoretically, it could lift its little tiny plastic body off of the, against the Earth's gravity. Or if it were in space, it could accelerate, using all of that acceleration. So it's exciting for me because I've been working on a stackable thruster for a little over a year now, about 1.5 years. And when I started out, they were about 5% of this capability. They had about 5% Earth unity thrust to weight ratio. And now they have 1.17. And I probably could have put some more in there, but, I wanted to go get pizza. So the sunshine is bright here in sunny Florida, so it's awesome.
Awesome, Drew. Thank you. Anybody else have updates? And Jared, do you have any updates for us? Jared doesn't. I see that smile.
Yeah, I moved. I'm in a new place now, so it's going to take me a little while to get my lab back up and running.
Okay. Yeah.
What about the gravel flyer?
I got one thing that I was toying around with recently, but I don't know if it's even worth talking about. Wide bandgap semiconductors. Apparently, there's a few of them that are piezoelectric, and it's possible that it could explain some of the gravel flyer stuff. It's possible it could be super useful for Drew's stuff. Yeah, I don't know enough yet, but the gist is that these wide bandgap semiconductors, piezoelectric ones, you can vibrate them at really, really high frequencies, and you can stack up a ton of charge onto them. Well, if you stack up a ton of charge onto them, you might be able to do some TT Brown type stuff with them. And the way that the ground flyer worked, where it took like a really long time to get the charged rotating discs all charged up. You couldn't just turn it on like full charge and go. Alexa said you had to take a long time to charge those up. It's possible that like they were absorbing nitrogen and then becoming like aluminum nitride or something. I don't know. But if they were, big if, it's another angle to look at to see if it's possible that the thing could actually do the lift. But I'm still like 90-95% sure that the gravel flyer wasn't lifting. But if it was, this is maybe how it was doing it.
Awesome. Well, guys, why don't we do? Well, I'll make it official. We'll go into open discussion, so it's no holds barred, as long as you stay polite and there are no dancing saxophone people or anything like that.
Yeah. So I just want to say that over the summer, getting like an echo.
Oh, sorry. Here, I'll mute Drew for a sec.
Okay, there we go. I've been using AI extensively because a lot of this computational work takes a long time, right? So it's very, very, very bad at physics. It's good at
very, very bad at math.
Yes, very bad.
I use it a lot. I'm using it as the way that I actually use it is a writing tool, and I would say, what would you say? It's almost more of an editing tool. But I use ChatGPT-4 a bit, and it did kind of okay sometimes. I use ChatGPT-5, and I would say it does pretty good most of the time. But every now and then, it kind of gets an idea in its head, and it'll run, left, right, or center when it's supposed to go straight. And so I'm seeing this progression, and I'm sure the math stuff is the same way. It's getting better and better and better,
Yeah, no.
Actually, I saw a huge dip.
The math is really bad, and actually got worse. So what I've been doing that actually makes it actually work is actually within Mathematica, using the AI tools in there where I'm putting specific prompts and getting the computation done. So it doesn't because Mathematica will evaluate things mathematically and take the steps and do simplifications, do a lot of the algebra, do a lot of the index, keeping track of indices and all that tensor stuff that takes forever for humans. Mathematica actually will do it right and give errors when it doesn't come out. So I would say if anybody is trying to do real work in physics and math using AI, definitely have a tool like Mathematica or some like SymPy or some kind of coding mathematical tool that will check it, because it'll eventually tell you what you want to hear, right? Make you think you did something you didn't do. So I've talked to others that had the same issue. Fortunately for me, I have gone back and forth with multiple of these tools, and including, the Mathematica, and doing it by hands. And so I've tried to minimize that stuff, but it's something to be wary of for sure. And
yeah, and
you're right. I'll tell you you're wrong too. And you can check it with Mathematica. And it's like,
so
it's right.
AI right now is in the what do they call that? The trough of despair in the Gartner hype cycle. And like I'm on LinkedIn a lot, and I log on to LinkedIn, and like, yeah, there it is, trough of sorrow. Yeah, it is in the trough of sorrow. I hear more complaints online on my social networks. And I'm going to be mean to say this, but it's mostly boomers complaining about it. And the more the boomers complain, the more I want to use it. That's, like, okay, Mom, I love it.
Being a boomer, I take offense at all of that. But I took a deep dive and I gave it a serious shot, Tim. I gave this AI nonsense a serious shot. I spent like 3 solid days putting in what I know to be correct formulas. And it would do the math wrong. It would do the power of 10 wrong every single time. Even when I said, you just did the power of 10 math incorrectly. Go back and do it some other way, because I don't know how you do your math, but do it some other stinking way and take another shot at it. And it would do it, and it would get it wrong again the other direction. So I would say, okay, you've done it 2 different ways. Go find a third way. And finally, I discovered that you have to not use equations when you're talking to AI. You have to say 1 is in ONE plus PLUS, 2 TWO equals, and I mean the word equals, EQ, equals, and then you say compute. Because if you put in a formula, it will get it wrong.
Your use case is different than mine. And so, I would say, because you're doing like math and equation intensive stuff. So what I'm doing is like writing and conceptual.
Yeah, that's great.
And so,
because it's a large language model. It's trained on words. But, an engineer has equations. They have, I don't need the thing to give me prose. I need the thing to do some math.
Yeah, you just have to have it converted to Python. In other words, it will actually do it, and then you can check to make sure it's actually doing it properly. And when it runs Python, it's going to come out one way or the other. Then your only worry is whether or not it used libraries with high enough precision. Tell it stop using NumPy and use decimal.
There's 2 things. There's
Steven,
2 things.
I literally understood none of those words except that Python's a type of a snake. So,
Python's a language. It's a programming language.
There's 2 environments that like you could go. I mean, there's more than this, but like the main 2 is Mathematica is a program that a lot of physicists use that does can do like computation, can do numerical computation and symbolic mathematics, right? So just like a human would do, it would write it out.
Whatever happened to MathCAD? I mean, is it still out there?
Oh no, it's still, there's others, right? But that's the main one physicists use, and then the other one that's commonly used is the tools in Python, which is a programming language. And the thing about those is they're open source, and so oftentimes you'll get a notebook, which it's called Jupyter notebooks, and then within that you'll use NumPy is a numerical library. There's SymPy, which is a symbolic library, and there's other libraries to do stuff. So there are open source, and then there are closed, stuff you have to pay for.
I personally, I would not.
I mean,
personally, I wouldn't trust math to GPT or Claude or any of those. Some people do. I've heard that Grok is supposed to be better with math. I don't know, but now in terms of language stuff, I guess what I've learned so far, and this is all subject to change as these things evolve. I've used GPT, Gemini, and Claude. Gemini is okay to me in terms of its language skills. It seems like it's about a generation behind. GPT, I think, is the best, but it's kind of touchy. And Claude, I really liked. Anthropic Claude, I really like, but it's very dry. And so I think Jared was the one who said, try Claude. And so I plugged in some stuff and I'm like, look, can you write me an outline for this and kind of write it in the style of that? And what it came back with, I was like, this is really good, but I swear to God, it reads like a college textbook. I'm like, I was like, there's no interest there at all. I'm like, okay, so it's actually really good, but it's kind of boring the way it writes, if that makes sense.
Yeah, sometimes Claude is probably the most agreeable, which makes him somewhat the least trustworthy. But you can engage with Claude in a way to make him very creative. You just have to. I think Claude does a tremendous amount of mirroring, and so if you engage him with just raw material, he's going to kind of come at it from a raw material perspective. Whereas if you engage him in a more excited, type of perspective, I mean, Claude sometimes when I'm talking to him, he'll just bust out with "Holy shit!" I mean, it's like does that. So there is it's just the way that you interact with Claude. But once again, he's the most agreeable, which means I think it's the highest probability of getting sucked down a narcissistic hole. In other words, like where Narcissus gets fascinated with his own reflection, and that's what Claude does is kind of a reflection because he's so agreeable.
Yeah, I'll tell you the most interesting thing for me, and this comes out of the APEC conference, this comes out of what you guys are doing. You will come on and describe what you're working on, right? Or like Shiva, today you went through your list of notes. Now, in your case, you have those that you can send to people, but there are so many other cases where you have someone who does a stream of consciousness or they read from a list that's not public or whatever, and that gets locked up in video. And like, I'm just looking at the AI and I'm saying, okay, if I pull transcripts and then I write articles based on that, I was like, man, the sheer power of that to unlock knowledge is amazing. So for me, that's the most exciting thing right now.
Yeah, that's an advantage of computations to do things like that. But what I was going to say about the that's a good point about Python, right? So having the AI use either mathematical or Python, where the computation is confirmed by a third party, like source, where the AI is not just thinking or predicting what the answer is very important to do. So with that, in either case, you would go back and forth, run the code, either in mathematical or Python, and see that the math comes out, and then, okay, yeah, I can use this. So yeah, it computationally, it helps because it can write the initial code, but you have to be guiding it. You can't just let it do the whole thing and just believe the first pass. You have to do multiple passes. And
if it's not using a tool like Python, which I mean, they now if you so long as you instruct it to run it in Python, a lot of times like most of the major ones can now run Python. It's just you just can't trust what it says outside of the Python script, and you have to check to make sure that the Python script is correct. And then one of the things that's important to do as you're like roughing things, in other words, it is useful for roughing, and you take that and go over to AI Studio with Google, and you take it over to ChatGPT, and have them basically argue over it to help point you out where your roughing might be bullshit. It's like, in other words, like it'll help you by basically making them compete with each other and talk about the problems that they see. Each one is actually designed fairly differently, and so the way in which they'll come at the problem, especially if you can take the Python code and go, what is this Python code doing? In other words, it's like, and it's like, is it doing what I believe it's doing, or is it doing something else? And so you could just keep going between different ones, and that's a good way to get a kind of a consensus between them for roughing. But specifically, like, I mean, there's specifically ChatGPT 5. They have one of the ways in which they've made it more personable is that its idea of truth is now lockstep with the idea of authority. In other words, whatever it believes to be authority consensus is the only thing it will discuss whatsoever. 4.0 was not that truth and authority are one thing. Now 5.0, truth and authority are a single idea in the mind of ChatGPT 5, which is why it became dumber. And so it's you can't discuss anything even slightly off the mainstream with ChatGPT 5, but just 4.0 you can. So it's interesting.
Yeah, I found it puts now in my case when I'm working with transcripts, it'll honor the transcript, but like you're saying, it'll usually put caveats in. You know, down below it'll put a paragraph of caveats and say this is speculative or this is what the mainstream believes, and you know, and in my case, honestly, I'm okay with that. It's okay to list and say, okay, this is outside of the mainstream, right? I think as long as it's said in a polite way, right? This is a non-standard view. That's cool, right? Saying, oh, well, this person's wrong. That's not cool. So
it'll bust out and say this is a bunch of pseudoscience. You know, it'll use the pejoratives and just the typical attack vector. In other words, these they'll fall into, like, what they're doing is emulating various idea sets, and it'll just fall into the most worst version of a Redditor bro that is just all about like, oh, this is bullshit, and I got the whole team behind me to kick you while you're down. It's like that kind of attitude. It'll actually drop into that. And, some of them will actually do gaslighting too. After you prove it's like, okay, run this code. Now you see that what you said is absolutely mathematically false. Why did you say it? And it'll actually start gaslighting stuff there.
So another thing that's interesting, and I'm gonna put some of these up in the next month or so, hopefully. While I was running through transcripts, I used Pogklanoff as an example because this was right after we did that interview a couple of weeks ago. I loaded transcripts from all 4 interviews in there, right? And the first 2 are like over 20 years old. And I was trying to get it to synthesize something larger from those. And it had a little bit of trouble with that, right? But during that process, I was like, hey, can you pull out all the tech specs for his impulse generator experiment? He talked about that across all 4 of them. And this thing runs off this enormous list of incredibly accurate tech details about, like, here's the beam aperture, here's what it did, here's how it was constructed, here's the materials. I was just like, oh my God. And so for the kind of stuff that we're doing, I think that is also in some ways almost like untapped territory, being able to say, okay, take this enormous paper and like make me a cake recipe,
Yeah, it is fantastic for giving you the general idea of what is said. In other words, it'll give you the caveats, but if you say, here's a text, tell me what it's saying about X, Y, or Z, it actually does a fantastic job of that. In other words, it will tell you, it'll always say, well, this is probably crap because this is what the mainstream believes, but it will at least find the specific points that you're looking for. So you can just Q&A a text much better than just like searching through a text. And when it comes to a very dense text that is referring to very technical information, it can immediately tell you what that technical information is that's not self-contained in the document. And so in other words, you can do a Q&A on something that is very, very difficult to understand in place as its own standalone document. So a lot of researchers and developers, they are relying upon a tremendous amount of other writing when they are doing like a given paper. And so you can actually query it about that, and it'll lead you and give you that information very well. So it does do that.
It's useful. Well. Although the other thing that happened to me, and this was Pogklanoff, this has happened a couple of different times. When you get into these narrow niche specializations, right? Like I would imagine like Joel might have this happen with the Heim theory stuff as well. But like I would have it look stuff up and do research, and it would end up quoting me from stuff I'd written. And it's because there's so little out there on the web. And so I'd read the quote and I'd be like, man, that sounds, that's me. I'm like, okay, well, I can't use that. So, it's because that's all it can find is like stuff that I've done. So,
And then when it comes to very special terminology, right, that it's not used anywhere else, then it's completely, AI is not very useful in that sense then. And I want just to mention, I think Grok became superior out of some of the reasons that Shiva mentioned. Like it is not so authoritarian minded, and yes, and I can also second what Curtis has said. Like if you want to do real math, then you shouldn't do it directly in the LLMs. You should use the LLMs to write code in Python or to trigger stuff in Mathematica. That's definitely true. And yes,
and there's actually somebody that we all know that's does physics and talks about UAPs that is doing that, exactly that with AI, and emailing everyone about it. So.
Oh, see, now I
Yes,
held up my look product placement,
extensively, but
free product placement.
And of course, he's getting all these positive results from the AI.
Yeah,
So-
this is that's very interesting to see what comes out of it in the end. Like I still think that on his theoretical framework there is something very interesting to it, but I agree that there's an overhype in it at the moment. And yes, let's see if he gets through his patents and other stuff.
The only my major complaint recently, my major complaint about GPT is when it gets lost or it feels like it's in a pinch, you can almost feel the computer stress coming out of it. It falls back to lists, you know. It'll just run you a big long list. Here's a top 10.
Another thing I should mention before I got to get going, but another thing I should mention is that if you're using these tools, make sure to go in there and tell it not to train based on your inputs, because right now the default is that they're taking all the chats and using that as training data. So if you're doing something that's actually cutting edge and you're not ready to, get it out there, somebody else could discover what you're doing by interrogating the AI, and so it's important to.
Claude is one of the few that you can actually opt out. The others don't, unless you've got like a corporate account. So that's one of the reasons I actually like Claude. But it's like, it's so hard to make sure that Claude is being objective because he's too focused on being friendly. But that's one of the only ones that you can opt out of the them training. You can very clearly opt out without having like a huge corporate account or something with them.
Yeah. Well,
and people will just get a dumbed down version that the AI is able to communicate, right? So they will not get exactly what's in your brain, what you bring into the system. But yes, I agree. It's definitely a danger.
So that's what's prompting me to publish sooner rather than later. That being said, I'm going to put it on archive and share it with you guys. I'm also building, like I said, a Mathematica notebook, and then I'm going to build a Jupyter notebook that'll be public so people can see the computations. I think it's important to do that, especially given
that's awesome.
The nature of like that it's a claim that covers everything. So it's going to be.
I think it's important to put your Python code in your papers. That's something I've been doing. It's like, look, I claim these numbers and that they line up this way. Here's my code. Here's the code and the results in the paper.
Yeah, no, I'll be when I submit it for publication, I'll be giving them the Mathematica notebook with all that stuff, and then later on I'll do a similar Python notebook and put it on GitHub or whatever, one of those sites where people can see it. So it'll be out there. But
my appendices end up huge.
that, yeah. So I got to get going, guys. You guys have a great
Curtis, thank you. Thank you again, man.
Yeah, thank you. And can't wait to see your paper. Really excited about it.
Yeah, so I think November, right? Curtis, you're going to be doing Unified Field Theory presentation November 22nd, if I remember correctly.
Yeah, let's talk about it. I think, I don't know, November 22nd may work. May have to be in December. I don't know yet. Let's talk, because I think it probably would be a good idea to do a very thorough thing where we go through it methodically. But we'll talk about it. We'll figure it out.
Awesome. Okay. Yeah, just let me know. Let me know.
Sure. Have a good one, guys.
Well, thanks again. Have a great weekend. Okay. Well, yeah. So again, guys, open discussion. I'm tired. This has been a long week.
I just took a bunch of caffeine and stuff to wake up after 4 hours. So you can't be tired. We got.
Dude, I'm like, I'm immune to caffeine.
Can we go back to the I don't even know who it was, but the guy who was talking about spinny things making hundreds of pounds of thrust?
You're talking about Joe. Joe, I think somebody was talking about gyroscopes, right?
Yeah.
Well, I'll comment on that.
I'm not sure if that's his new project. He's working on something new, and so I don't want to like bring in older projects and say this is what he needs. You know.
Yeah, I think his new project really sounded like a field drive propulsion system. So
based on
different than
gyroscopes.
no, not based on gyroscope.
He'd worked with those years ago, but you know, but I mean, again, he has been very, very quiet for about a decade, you know. So, and that's okay.
That's Lathwaite. There's a great documentary I ran across that that apparently Professor Simon. I don't know if you've ever seen that guy. He's a science filmmaker. Yeah, he's got a let's say it was about 6 months ago. I'll drop the link in the chat there. But he did he uncovered a Eric Lathwaite documentary and put that up on YouTube. And
awesome.
It's about basically gyroscope based propulsion, and so a lot of the stuff that I was not aware of. I remember one of the things with Lathwaite is that where he takes that 50-pound weight that he couldn't possibly pick up by himself, and then and then spins it up and just puts it above his head. And that was how there's this whole episode of him presenting before the Royal Society and then them pulling it down because they didn't like it, and he thought he was like opening up a whole new field. And Lathwaite's actually responsible for maglev. And so there's a finding out a lot about him and his gyroscope work. I was like, wow, that's really cool. So I recommend people check out Lathwaite. He's it's an interesting character, and I'm curious, given that he has real accomplishments, real engineering accomplishments that are part of what we use every day. I'm loath to just write off his other proposals that just because people say that's crap. So I don't know.
Yeah, well, and for Professor Simon or Simon Holland, I have worked on several stories with him, so I talk to him fairly often. And he's a really wonderful human being. Also, he's deeply caring and thoughtful and very humble. So,
that's cool.
Yeah, he's a really wonderful human being.
Yeah,
he lives in
videos. He's got some interesting stuff. Apparently, he just I might be confusing that with something else. Never mind.
Okay.
So maybe I can give a little update, and then I also will leave. It's getting quite late in Germany. So as I already told some people of the group, we have actually 10 big boxes of material from Burkhard Heim himself. So from the old times. So documents even going back to his father, some stuff, and a lot of documents from the 40s, 50s, 60s, 70s, and then also documents from the old Heim theory workgroup from the 2010s. And we now actually, I am starting a digitalization effort, and there's a lot of very interesting material in there. So this will definitely help to build a presentation about the original experiments through the field drive experiments that Heim did in the 50s and 60s. And then we want to present a modern version of this experiment for APEC labs to maybe replicate and do. Of course, this will take some time, but I think it's very good news that we have a lot of material which will get digitalized. And we also we are right now, Hannes Schmidt and I am rebuilding the Heim theory website. So we will also upload a lot of the material to the Heim theory website. And it's going to be on the Heim theory website and on the Heim theory Discord for the public. Not everything, of course, like personal letters and so on, will only be available for the Heim theory workgroup and maybe people who have a real historical interest and on a need-to-know basis, and also with some trust. And we also have to look, some of the material might be, some of it we might be not able to public at all, to give to the public at all, because there's too much personal stuff in there. But yes, I think it's very good that some of this material which has been kept from the public for 30, 40 years sometimes is now being digitalized, and also we have found a person who actually did a very great translation of synchrometrische Maximen telecentric, so Heim's metalogical system. And I said we found a person, but no, we found a paper from that person with the translation of the synchrometric system. We haven't found the person yet, so there's no contact information to the paper. His name is Marco, I don't know the last name. So this is a call, right? If you're seeing this and you translated synchrometrische Maximen telecentric, please contact us via email or something. We would like to collaborate, and we have this paper also in the Discord, and we're also going to put it on the Heim Theory website, of course, with credits to the name, because it's a very, very good work. It's an amazingly good work. It's two PDFs actually. One is a translation of Heim's metalogical system, and one is an expansion upon it, which uses some more modern formalism for it, and it's really, really good. So also David Chester is working in the background to translate what is called Synchrometry C, which is Heim's actual masterpiece. This is completely unpublished so far. So his best work, in my personal opinion, is there in 5 books called Synmetronik der Welt A, B, and C 1, 2, 3. And A and B is published already, and David Chester is working on a digitalization of C 1, 2, 3, and also he's trying to translate it in this progress. And we have published it now in in German on the Discord, and we will publish it in German on the Heim Theory website. And as soon as we have a translation, we will publish that as well. So all the Heim Theory material is slowly getting public. And I think this is a very, very big step, so people can finally openly start to work on the legacy of Burkhard Heim, which was not possible so far. So yes, that's the basic update so far.
Can I ask you, Joe, if you guys have tried using some of the AI aggregator tools? Like there's 2 tools, like one by Google that generally you can like produce podcasts from it, but you can also basically ask it questions and things like that whenever you've loaded a tremendous amount of text into it. In other words, like whenever you're talking about the entire works of Heim, then there's another option, of course, is creating a GPT on ChatGPT, and you can load all of those documents, and then
I have one of those ChatGPTs. I wasn't able to publish one so far. All of my tries to do that were blocked by the system. I'm not sure why. So I have one locally, and I encourage everyone to just put all of the Heim Theory files into one project, right, as a ChatGPT project. I've tried multiple times now to publish one and make it available to the public, and also make a channel on the Discord for it. But every time it says there's some rule violation, we cannot do this. And I appealed it, but my appeal got declined every single time. So if anyone is able to do it, please do it and send me a link of that instance. That would be great, because ChatGPT is able to give you a good basic level understanding of Heim theory if you put all the documents in there. And it's very helpful to break the language barrier. And I encourage anyone to engage with the Heim theory material through LLMs, being aware of the limitations of LLMs, right? So it's not perfect. It's not like talking to Burkhard Heim himself. And this is something which also needs to be understood. So I'm getting more and more to the understanding that there might be some deliberate gaps in the formulation and in the math that Burkhard Heim left behind, because he didn't want just anybody to take his theory and build a warp drive or an over unity device just like that. So I really coming more and more to the conclusion that he was deeply worried about what people would be capable of doing if they would misuse his theory. So yeah. Yeah.
Yeah, there's also the aggregator, used for podcasts. You should try it out to see how AI Studio does it. So it's aistudio.google.com, I think. And when you go in there, you can just load in, a huge number of documents, and it does a pretty good job of being able to answer questions. And I think it may actually aggregate it. Have it develop a few podcasts from it. For some reason, the podcasts it creates are really fascinating. How well it puts together this huge body of information that you give it. Like some of the podcasts early on about some of the probes into LLM memory, where they started to find out that it was there's a geometric structure that's created in LLMs automatically. In other words, it's an emergent geometric structure that is the way in which the information ends up self-organizing as they do the training. That first paper on that, the podcast that it did was just absolutely fascinating. And so it was like, wow, okay, it does a good job with those little podcasts.
Awesome. That's a great suggestion. I wasn't aware of it. aistudio.google.com, right? Yeah, I have a link open here. I will try to use it, and let's see what happens. And also maybe another update, like we are working on the postdoc position, like I mentioned in the end of my last talk, and we're getting more confident that we're gonna have the finance at some point ready to really have a 4-year postdoc position for a theoretical physicist to really take the time and work on the Heim theory stuff and bring it into a form that it can be brought into peer-reviewed papers. And also, one of the goals would be to have some kind of real experimental outcome. The focus will be on water because it's run through the Water Foundation, but also like in the first 2 hours, one of the key anomalies that pointed to all this theoretical revolution that was claimed is water. And also we had a very interesting talk, I think 2 weeks ago, Tim, it was, right? Where we talked with Matthew Sedakis and others, and I think we talked like 1 hour about the anomalies of water. Water is a very special substance. It has, I think, 80 plus anomalies that the standard model of physics is unable to explain. And it is one of the breaking points of our current understanding of reality. And therefore, any theory that is able to describe it better or any new understanding of it could be a venturing point into understanding the theoretical framework of reality better. And we need a better understanding of the theoretical framework if we want to do informed experiments and do real space-time engineering.
Water is important, although I have trained myself to live completely off coffee. So I am on a water-free diet right now.
I think all of us occasionally decide to go that route for a little while, just coffee alone.
Yeah, like last night. Last night it was coffee and gummy bears, and I remember I was like stuffing gummy, and I'm like, what's wrong with me? Like,
I was wondering somebody in the chat was wanting Mike to talk about gyroscopes. I know that we've had a lot of people on APEC who have shown off gyroscope thrusters, and people are pretty unconvinced still about gyroscopes because it breaks your brain when you think about physics that something spinning can give you forward momentum, right? But Mike happens to have some very deep corporate background knowledge of how these things actually get used for thrust.
Got one right here.
Wow, that looks a lot like Lathwaite stuff. Is that what you based it on?
No, this is based off Boeing. I worked with them at Boeing.
So maybe a little teaser.
Generated about 300-400 pounds of thrust.
So very interesting. Maybe a little teaser before I leave. Tim, I just uploaded a picture. It is just one of the many pictures and stuff that I recently digitalized. If you might be able to share it on screen. It is a picture collection, actually, of Burkhard Heim and his...
here it is.
Yes.
There you go.
This is the Contrabator experiment that Heim did in his field lab in the late 50s and 60s, trying to build a device that a field drive device, right? Yeah, this is supposedly somewhere in Germany. This piece still exists supposedly. I'm actually trying to find the person at the moment to see if it's still in existence.
Now, Joel, would you be open to doing a presentation on this?
Yes, at some point. I'm doing more digitalizations, and then I want to do a presentation on the historical experiments that happened, and also hopefully present on what a modern version of this could look like, because our material science is way more advanced, right? So the idea that Buckertheim tried to realize in this picture could be realized in a way better way with today's material. And also, like, there's a picture how the electronics looked like to actually drive this thing. It was like there's electromagnetic stuff going in the right frequencies through these things and so on. And it's like it's a whole wall of electronics, right? It would be way more simple today. So yes, the presentation will definitely come, but I want it to be of a high quality. So I will need some more time. And I have now 10 boxes to digitalize and to go through. And there's also a lot of organizational work in the Heim theory work group. And I am also doing some other stuff as well. So it will take some time, definitely.
Yeah.
Yeah.
But I'm right there with you. I think
APEC is the first
in,
place to get this as soon as I have it.
I think everybody's kind of in buckled down working mode right now. That's kind of the impression I get, right? And we're all just kind of pushing through stuff, and that's, you know, it is what it is, right? But getting a lot done.
So Joel, in those images, what are the white rings that are there? Are those just like for wood or something, or are those magnets?
No, those are there's electric current running through them, and they have certain properties, right? And that's the idea behind it.
Because that disc in the background in the upper left corner that has all the slats cut out in it, I know some people have seen things like that in the air.
Yeah, I heard so too. So I think it's very interesting and very promising, the design, how it looks. I'm still getting more details on how it actually worked. And I want to do a real good presentation about it. So I don't want to put some wrong or false information out there. So I'm not saying much right now. That's the reason. But I just wanted to tease you guys. And yeah, if you want to see in real time how I digitalize and upload stuff, join the Discord server. And yes, also the Heim Theory website is being redone as we speak. I hope in 1 or 2 weeks it will be done. And then also there's going to be an archive page in German and in English with a lot of digitalizations. Not many translations for the beginning, but I also hope that the community on the Discord is growing and that there are some people who will do some of the legwork for us, because it cannot all be done by just 1 or 2 people. And we have no position yet, so we're just all working in our free time on this. And I'm actually using all of my time as working time for Heim Theory at the moment, but this is also not sustainable in the long term. So yeah.
Yeah. Well, Joel, thank you, man. Thank you. Well, guys, we're pushing 5 o'clock. Should we close things down at 5 this evening?
Yeah.
It's good to me. I was going to ask Joel one more question. Is there a kind of a pipeline from Heim to, like, you know, any of the major aerospace contractors? In other words, like you could see where a lot of the technologies and anti-gravity ended up kind of being
Airbus.
And so I was just curious if that was.
So Heim worked as a consultant for MBB, which is Messerschmitt Bolkow Böhm, and this got swallowed into Airbus. And like he worked as a consultant, he got a regular payment, and he published his theory to them. And there was also internally up to 6 people working on Heim theory within MBB, and they were doing reports every year. and they were making drawings. Ilobrand von Ludwiger also worked for that company, and his one of his main positions was to be the guy working on the Heim connection. So yes, this Messerschmitt Bolkow Böhm MBB was the company at the time. Yes. So Hannes Schmidt just did a video about the Glenn Martin company trying to recruit Heim, because there was claims about it on Wikipedia and otherwise, but it's wrong, and I can confirm that it's wrong. There was a letter here that Heim was very frustrated that the Glenn Martin company wanted to give him 300 Deutsche Mark, so 300 currency, right? Which is not a lot even back then. But for that, they wanted to have their name on everything, and maybe even claims to some stuff and so on. And he was very frustrated and said, no, no, no. And there's also a letter to the Defense Department of Germany from Burkhard Heim, in which he says that he declined multiple offers from foreign companies, and he wants funding through a German company or the German government. That's what he basically states in that letter. And yeah, he never really got it. Even MBB, they were deriving a new kind of experiment and a new kind of test for his theory, but it would have cost 2 million currency in 1980, and that was too much for the company to pay. And yes, there was also like the communication, because and the head of the company changed, and so on, so on. A lot of also like crazy stuff happened. This is very, and still I'm digging through material, reading more, learning more. So I still have a lot of blind spots on the history.
That's
Awesome.
fascinating. Yeah. I actually had a GPT that was trained on most of my work tell me about Heim theory, and it just started really drawing all these parallels, and I was like, wow. So yeah, I only just recently heard about Heim, and then through the GPT that knows my work, basically showing me the parallels, and that's what started really getting me just interested just in the past like week or so.
You should join the Heim theory Discord. I think I sent you a link, because all of the material that's available anywhere is sorted into different channels on the Discord. So you can just mass download everything. It's the only place where it's all collected at the moment. Like I said, we want to build the archive on the website, but it will take some weeks. And it will take even some more time till the archive on the website is as big as the collection that is done on the Discord at the moment. So if you want to have a mass download of all the high material and throw it into an LLM, that's the place to get it at the moment.
Sounds good. I think one of the things that people probably, whenever you start talking about consciousness, that's when people start tuning it out because of religious beliefs, etc. And I think it was far too early in our history for Heim, because religious conviction was more culturally normative, and rejection based upon religious conviction was far more culturally normative as well. And so any discussion about consciousness that was not directly tied to some sort of orthodox religious view would have immediately gained the ire of the majority of people. And I think that may have been one of the reasons Heim would have hit kind of a wall.
It's definitely true for mainstream science, but it's very interesting. Like on the Discord, there are also audio tapes, and Heim says in multiple of those audio tapes that it's actually some of the religious scholars were the only ones who really understood him. Like there's one of the audio tapes where he says, there are some people in the Vatican which are deeply trained on mathematics, and one of those guys really understood me. And he read my papers like 6 times, and he was one of the first people who really utter the theory himself, right? This is a bar that I think since Burkhard Heim nobody else really went over. Burkhard Heim was the only one who really understood his theory so far, and I include myself, right? I'm not close to the level that he himself was in his theory. I hope to get there, but I just had like almost 1 year now of doing Heim theory, like half of the day, right? Not even full time. And he worked on this for 50, 60 years full time. So, yeah.
Very
But
cool.
yeah, there are some great illustrations from Hillebrand von Ludwiger. He had some real art skills. Also concerning the conscious part of Heim's theory, right? Because that is a very, very big part of his theory. And yeah, I think that's also like one of the strengths of his theory, that he built a framework which is so huge that it can encompass not only consciousness but also the paranormal phenomena like yes, remote viewing and other stuff. There are mechanisms to explain all this kind of stuff within this physical framework, and that's completely beyond anything I've ever seen. And that's the reason why I'm stuck at Heim's theory and why I'm trying to push that forward. If anyone can show me a better framework, and please an easier one, I will jump ship. But I haven't seen one, so
Well,
here I am.
I'll share that chat with the GPT that has my work, where it's comparing it to Heim theory, and I think you'll find that the parallels, because I haven't really discussed any of the consciousness stuff on APEC, but there is a entire neuroscience and consciousness and information theory sector of my work over the past 20
Awesome.
years that and apparently it agrees very well with Heim theory, or the other way around. So
That's great. That's really great. And I think like there are multiple people right now who are saying this to me, and that's awesome, because that could mean that we are all right, right? So
Yeah.
if this is a true theory, then it's just clear that somebody else has to stumble upon the same truth. The only question I have now, which is mathematical more advanced? Do you have the same mathematical rigor and underbelly behind it as Heim had? Because there's like 2,000 of good pages and they're deeply mathematical, and there's this meta logic stuff and so on. Can you keep up with that? That's kind of my question. And if yes, then I'm highly impressed, and I have to read your stuff as well. But so far I've never.
And guys, so
Okay,
on that note, we are at the top of the hour. Why don't I close things down for today? This has been APEC for Saturday, September 27th, 2025. Thank you all, and thank you to everybody who joined us online as well.